Hello everyone, I'm Big Cat. In this section, we are making atom objects, which are objects that are picked up after the atom is picked up. Before you can make a weapon object, you need to make the weapon skeletal sockets. Sockets are used in weapon atom objects. First, let's understand what the skeletal sockets are. Open a static model of the M4. This is what the M4 weapon will look like in its complete state with on sights on it. Use this model when the weapon is on the ground. Open the M4's skeletal model. Use this skeletal model in the weapon object. There is no backstock and no magazines compared to the static model. This is because the player can change the backstock and magazines, so they are absent here by default. How do I display the backstock or magazine model in the skeletal model of the gun? This will require sockets. Open the weapon skeletal. All bones are shown in the skeletal tree. Right-click and select Add Socket. This creates sockets for the skeletal. The blueprint allows you to bend all the models in this socket, which is then displayed. Here, you can right-click and add a resource preview. The models are then displayed to the correct position by adjusting the socket's position, scale, and rotation values. The models added here are only visible in the editor and will not be displayed when running. This is the basic use of the skeletal sockets and what they do. Remove the sockets for testing. Next, we will make the sockets for this M4 weapon. First, create a socket under the magazine socket skeletal. Name it Socket Match. This socket is used to display the magazines. Add an M4 magazine to this socket. The magazines are in the correct position. Create a socket under the bolt skeletal. Name it Socket Backstock. This socket is used to display the backstock. Add the gun backstock model. Make the backstock position correct by adjusting the position of the socket. Create a socket under the root ball, named Socket Muzzle. This socket is used to display the rifle muzzle. Add the rifle muzzle model. Make the muzzle position correct by adjusting the position of the socket. Create a socket under the root skeletal, named Socket Sight Default. This socket is used to display the M4 default sight. Add the M4 exclusive sight model. Make the sight position correct by adjusting the position of the socket. Create a socket under the root skeletal, named Socket Sight Holographic. This socket is used to display the holographic sight. Add the holographic sight model. Make the side position correct by adjusting the position of the socket. Create a socket under the root skeleton, named socket site 4x. This socket is used to display the 4x site. Add the 4x site model. Make the site position correct by adjusting the position of the socket. Create a socket under the root skeleton and name it socket for a grip. This socket is used to display the grip. Add the grip model. Make the grip position correct by adjusting the position of the socket. M4 has a total of 5 parts that can be placed. Delete all pubg resource. Save. Next, make the sockets for the AK weapon. Open the AK weapon skeleton. Create a socket under the root skeleton, named socket match. This socket is used to display the magazines. Add the magazines model. Make the magazine position correct by adjusting the position and rotation of the socket. Create a socket under the root skeleton, named socket muzzle. This socket is used to display the muzzle. Add a model of the rifle's muzzle. Make the muzzle position correct by adjusting the position of the socket. Create a socket under the root socket, named socket site default. Although the AK does not have a default site, a socket needs to be added for uniformity. This socket will not have a model attached to it, so there is no need to set the position. Create a socket under the root skeleton, named socket site holographic. This socket is used to display the holographic site. Add the holographic site model. Make the site position correct by adjusting the position of the socket. Delete the previous resource. Create a socket under the root skeleton, named socket site 4x. This socket is used to display the 4x site. Add the 4x site model. Copy the position and rotation of the holographic site. In total, there are 3 parts of the AK weapon that can be replaced. Delete all previous resource. Save. Next, make the sockets for the AWM weapon. Open the AWM weapon skeleton. Create a socket under the root skeleton, named Socket Match. This socket is used to display the magazines. Add the magazines model. Make the magazines correctly positioned by adjusting the position and rotation of the socket. Create a socket under the root skeleton, named Socket Muzzle. This socket is used to display the muzzle. Add a model of the sniper muzzle. Make the muzzle position correctly by adjusting the position of the rotation of the socket. Create a socket under the root skeleton, named Socket Side Default. Although the AWM does not have a default site, a socket needs to be added for uniformity. This socket will not have a model attached to it, so there is no need to set the position. Create a socket under the root skeleton, named Socket Site Holographic. This socket is used to display the holographic site. Add the holographic site model. Make the site position correct by adjusting the position of the socket. Delete the previous resource. Create a socket under the root skeleton, named Socket Site 4x. This socket is used to display the 4x site. Add the 4x site model. Copy the location of the holographic site. In total, there are 3 parts of the AWM weapon that can be replaced. Delete all previous resource. Save. At the moment, we only have these 3 weapons. If you want to make other weapons, just follow this rule to make them. Since each weapon has multiple sets, each using a different socket, add these sockets' names to the data table. Open the weapon accessories table structure. Add the variable named socket name. Type name. Save. Open the weapon accessories data table. Set the holograph site socket name to socket site holograph. Set the 4x site socket name to socket site 4x. Save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making weapon accessories object. When the character picks up weapon accessories from the ground, it deletes the pick up weapon ACC object and creates a weapon accessories object. Create a new folder in the items folder and name it equipments. All equipments objects are placed in this folder. Note here that weapons, weapon accessories, ammo, and equipment are all placed in this folder. Create an actor in Equipment and name it Atom Weapon ACC. Open. Click on Class Settings. In the Details panel, set the parent class to Atom Base. Add a variable named Datas. Of type ST Atom Weapon ACC. Add a variable named ACC type. Of type E-Weapon ACC type. Compile. Open construction script and initialize the weapon accessories it needs, since it inherits Atom Base. This object is already set with ID and SN when it is created. Get the weapon accessories state in the weapon accessories table by ID. Set the weapon accessories data to Datas. All the information for that accessories can be obtained by calling the Datas variable. Call the init function of the Atom Base class. Set the Atom tab to Accessories. Set the name of the atom by Datas. Set the type of accessories. Override the getWeight function. Get the atom weight via Datas. Compile, save. The weapon accessories will be displayed in the weapon object. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, create a weapon object class and set up weapon model related function. When the character picks up a weapon from the ground, it removes the pick up weapon object and creates a weapon object. Create an actor in Equipment and name it Atom Weapon. Open. Click Class Settings. In the Details panel, set the parent class to Atom Base. Add a skeletal mesh component. Use it to display the skeletal model of the weapon. Create a static mesh component in the skeletal mesh. Name it Mag. This is used to display the magazine's model. Create a static mesh component in the skeletal mesh. Name this component Muzzle. This will display the muzzle model. Create a static mesh component in the skeletal mesh. Name this component Sight. This will display the model of the sight. Create a static mesh component in the skeletal mesh. Name it Grip. This is used to display the grip model. Create a static mesh component in the skeletal mesh. Name it Bastock. Used to display the gun bastock model. This static mesh component displays the weapon's accessories model. None of these models need to be involved in physical collisions. Set to non-collision. Add variable named ammo. Type integer. Indicates the number of bullets remaining in the current weapon. Set this variable to be editable and to be exposed on spawn. Add a variable named position. Indicates the position of the character's back, where the weapon is currently located. Use enum tabs to improve readability. Create an enumeration file in the Datas enum folder named E-Weapon Position. Open. New, name it left. Indicate left. New, name it right. Indicates right. Save. Close. Go back to atom weapon. Set the position variable of type E weapon position. The weapon must select the back position after spawn, so set this variable to be editable and expose on spawn. Add a variable named isOnHand of type boolean. Indicates if the weapon is currently on hand. Set this variable to be editable and to be exposed on spawn. Open construction script function. Find the weapon data by ID in the weapon data table. Expand the structure. Save the weapon data as a variable. Name it data. We'll probably use the weapon data a lot later, so save it as a variable for direct use later. Call the init function of the atom base class. Set the atom type to weapon. Set the name of atom via datas. Next, initialize the weapon model. Set the weapon skeleton model first. Compile. Open my character's event graph. When the 1 key is pressed, create a weapon object to the level. Add the spawn actor node. And class select atom weapon. Create a transform. Add a cube to the level. Copy the location value of this cube to the spawn actor node. Set the ID to 1 and the SN to 111. Return to the level and delete the cube. Run the game. Press the 1 key. The weapon is displayed in this level. This is because setting the model is set in the construction script of the weapon actor. So the model is generated when the character is created. Go back to atom weapon. Add comment. Next, set up the component model. Add the sequence node. All weapons need to have default magazines. Create default magazines. Compile. Run the game. Press the 1 key. You can see the model of the magazine is displayed, but the position is wrong. Go back to the item weapon object. Create the Attach to Component node. The purpose of this node is to attach the target component to the parent component. The socket name is the location of the attachment. We have already created this socket in the previous lessons. Use the magazines model to connect the target variable. Use the skeletal model to connect the parent variable. The socket name is set to socket match. Set the rule for location to snap to target, which means to attach the model to the target value. Set the rule for rotation rule to keep word, which means that the model's position remains the same as the word rotation. The scaling rule is unchanged by default, indicating that the model's scaling remains as a relative scaling value. Compile, run the game. Press the 1 key. You can see that the position of the magazine model is displayed correctly. All weapons come with default muzzles in the weapon skeletal model, so the muzzles do not need to be set to the default model. You just need to attach the muzzle model to the weapon socket. Copy node. Connect the target with the muzzle model. Connect the parent with skeletal mesh. The name of the socket is set to socket muzzle. Only M4 weapons have default sight. First, determine if the default sight object reference is not null. If it is not null, set the sight model. Attach the sight to the weapon socket. Copy the node. Connect the target with the set model. Connect parent with skeletal mesh. Socket name is set to socket sight default. Compile. Run the game. Press the 1 key. You can see that the position of the model of the sight is displayed correctly. The grip accessories are only available for M4 weapons. Determine by can grip if the current weapon is an M4. If the weapon is an M4, you only need to attach the grip model to the weapon socket. Copy node. Connect the target with the grip model. Connect the parent with skeletal mesh. The socket name is set to socket for grip. Since the M4 does not have a grip by default, you do not need to set the grip's default model. If it's an M4 weapon, you need to set the default bust torque. So, you need to determine if the default bust torque object reference is not empty first. If it's not empty, set the BattleGrounds model. Attach the BattleGrounds model to the socket. Copy the node. Connect the target with BattleGrounds. Connect parent with skeletal mesh. The socket name is set to socket BattleGrounds. Compile. Run the game. Press the 1 key. You can see that the position of the model of the BattleGrounds is displayed correctly, but the position is leaning up a bit. Open the M4 weapon skeletal file. Select the BattleGrounds socket. Set the position X value to -1.86 and the Z value to -3. Save and close. Run the game. Press the 1 key. The position is displayed correctly. All default components have been set. Collapse the set default components part into a function. This function will only be called in construction script. So set this function accesses to private. Set the category to private. Set the name to init default ACC. Adjust the node position. Select the weapon data to hide variables that are not used. Adjust the node position to improve the readability of the blueprint. Add comment. Double-click to open function. The first parameter is named mag static mesh. The second parameter is named site static mesh. The third parameter is named can grip. The fourth parameter is named BattleGrounds static mesh. Adjust the node position to improve the readability of the blueprint. Compile, save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. Weapon accessories will change according to the player's actions. In this lesson, we are going to make and update the functions related to weapon accessories. Open the item weapon object. Next, create the setup component function. Create the function and name it updateMatch. Set the category to public. Use to update the magazine's model. Add input parameter. named mag-acc actor. Tap Atom Weapon ACC object reference, used to indicate the magazine's object to be displayed. Save the accessories object to the weapon object. Name it ACC mag object. First, determine if the weapon accessories object is empty. If it is empty, prove that the magazine is removed. Set the default magazine in the weapon data to the magazine model. If the accessories object is not empty, then find the magazine data through the weapon accessories table. Only the model data is needed here. Hide the other data. Determine if the current weapon is an AK. If it is not AK, set the static mesh to the magazine model. If it's an AK, set static mesh 2 to the magazine model. Next, test the update magazine function. Open my character. When the 1 key is pressed, create a weapon object to the level. Save the weapon object for later use. Name it Test Weapon Actor. Call the multi-gate node when the 2 keys is pressed. Set the loop to true and add 2 output nodes. Execute Alt 0 when the 2 key is first pressed, Alt 1 when the 2 key is second pressed, Alt 2 when the 2 key is third pressed, and Alt 1 when the 2 key is fourth pressed, and so on in this loop. When the output is 0, a weapon accessories object is created through the spawn actor from class node. Set class to Atom Weapon ACC. Create a transform, and since this object will not have a display, all defaults will be fine. Set the ID to 11 and the SN to 111. Call the update magazines function. Set the magazines object. Copy the node. Connect Alt 1. Set the ID to 30 and the SN to 1313. Copy the node. Connect Alt 2. Set transform. Set the ID to 50 and the SN to 1515. Copy the node. Connect Alt 3. Do not set the magazine object. Compile. Run the game. Press 1 to generate the weapon. Press 2 and the magazines are replaced with expanding magazines. Press 2 again and the magazine is replaced with a quick magazine. Press 2 again and the magazine will be replaced with a quick expanding magazine. Press 2 more keys to replace the magazine with the default magazine. Modify the creation weapon ID to 2. Run the game. Press the 1 key to generate the weapon. Press 2 and it looks like the magazines haven't changed. This is because we are currently using the same model for the expansion and default magazines. The real has changed. Press 2 again and the magazines are changed to quick magazines. Press 2 again and the magazine is replaced with a quick expanding magazine. Press the 2 key again and the magazine is replaced with the default magazines. Modify the create weapon ID to 3. Set the first magazine ID to 12. Set the second magazine ID to 40. The third magazine ID is set to 60. Compile. Run the game. Press 1 to generate the weapon. Press 2 and the magazines are displayed with expanding magazines. Press 2 again and the magazines will be displayed with quick magazines. Press 2 again and the magazine will be displayed with a quick expanding magazine. Press 2 more keys to replace the magazine with the default magazine. Go back to item weapon. Create function and name it update model. Set the category to public. Use to update the model model. Add an input parameter named model ACC actor. Tap item weapon ACC. Use to indicate the model object to be displayed. Save the accessories object to the weapon object. Name it ACC model OBJ. First, determine if the weapon accessories object is empty. If it is empty, it proves that the model is removed. Set the model model to empty. If it's not empty, print the data for the model through the weapon accessories table. Only the first model data is needed here. The other data is hidden. Set the muzzle model to empty. Compile and save. Next, test to update the muzzle function. Open my character. Clone the multi-gate node. Connect the multi-gate node when the 3 key is pressed. Copy the create weapon accessories object node. Connect Alt 0, Alt 1, Alt 2, and Alt 3. Set the first ID to 4 and the SN to 44. Set the second ID to 6 and the SN to 66. Set the third ID to 8 and the SN to 88. Call the weapon object to update the muzzle function. Update the gun muzzle with an Alt 3 node, direct connection. Compile. Run the game. Press 1 to generate the AWM weapon. Press 3 and the muzzle is replaced with a compensator. Press the 3 key again and the muzzle is replaced with a flash. Press 3 again and the muzzle is replaced with a silencer. Press the 3 key again to remove the muzzle. Modify the creation weapon ID to 1. Set the first ID to 3. Set the second ID to 5. The third ID is set to 7. Compile. Run the game. Press 1 to generate the M4 weapon. Press the 3 key and the muzzle is replaced with a compensator. Press 3 again and the muzzle is replaced with a flash. Press 3 again and the muzzle is replaced with a silencer. Press the 3 key again to remove the muzzle. Modify the creation of weapon ID 2. Compile. Run the game. Press the 1 key correctly. Press the 3 key correctly. Press the 3 key again correctly. Press the 3 key again correctly. Press the 3 key to remove the muzzle. Go back to item weapon. Create function and name it update site. Set the category to public, used to update the site model. Add input parameter, named site ACC actor. Cap item weapon ACC, used to represent the site object. Save the accessories object to the weapon object. Name it ACC site object. First, determine if the weapon accessories object is empty. If it is empty, prove that the site is removed. Get the default model for the site from the weapon data. Set to the set model. Head the variables that are not used. Then reattach the set model to the default set socket. Copy the attach to component node. Set the socket name to socket site default. If the object is not empty, set the site model. Get the set data in the weapon accessories table by ID. Set the model to the site. Copy the attach to component node. Set the socket name. Head variables that are not used. Compile and save. Next, test to update the site functionality. Open my character. Copy the multi-gate node. There are only two types of sites, so delete an output node. Connect the multi-gate node when the 4 key is pressed. Copy the create weapon accessories object node. Connect the output node. Set the first ID to 1 and the SN to 11. Set the second ID to 2 and the SN to 22. Call the weapon object update site function. Connect the update site directly with the out2 node. Compile. Run the game. Press 1 to generate the weapon. Press 4 to replace with a holographic site. Press the 4 key again to replace the site with the 4x site. Press the 4 key again to remove the site. The other two weapons are also correctly. You can test them yourself. Go back to item weapon. Create function named update for grip. Set the category to public. Use to update the grip model. Add input parameter named ACC for grip (pubg). Type item weapon ACC object reference. Use to represent the accessories object. Save the accessories object to the weapon object. Name this parameter as ACC for grip object. First, determine if the weapon accessories object is empty. If it is empty, prove that the grip is removed. No weapon has a default grip, so set the grip model to empty. If the object is not empty, set the grip model. Get the grip data in the weapon accessories table by ID. Set the model to the grip. Head variables that are not used. Compile, save. Next, test the update grip feature. Open my character, copy the multi-gate node. Connect the multi-gate node when the file key is pressed. Clone the Create Weapon Accessories object node. Connect the output node. Set the first ID to 9 and the SN to 99. Set the second ID to 10 and the SN to 1010. Call the weapon object update grip function. Connect the update grip directly with the out2 node. Only the M4 weapon has the grip. Modify the create weapon ID to 1. Compile, run the game. Press 1 to generate the weapon. Press File, correctly. Press File again, correctly. Press the File key again to remove the grip. Go back to item weapon. Create function and name it update backstock. Set the category to public. Used to update the backstock model. Add input parameter named ACC backstock OBG. Type item weapon ACC object reference. Used to represent the accessories object. Save the accessories object to the weapon object. Name it ACC backstock OBG. First, determine if the weapon accessories object is empty. If it is empty, prove that the backstock is removed. Get the default model for the backstock from the weapon date. Set to the backstock model. Add variables that are not used. If the object is not empty, then get the backstock data from the weapon accessories table via the ID. Set the model to the backstock. Add variables that are not used. Compile, save. Next, test to update the backstock functionality. Open my character, copy the multi-gate node. There is only one type of backstock, so only 2 output nodes are needed. Connect the multi-gate node when the 6th key is pressed. Clone the Create Weapon Accessories object node. Connect the output node. Set the ID to 70 and the SN to 7070. Call the weapon object update BattleGrounds function. Connect the update stock directly with the Alt1 node. Compile. Run the game. Press the 1 key to generate the weapon. Press the 6th key to change the BattleGrounds. Press the 6th key again to restore the default BattleGrounds. Only M4 weapon has BattleGrounds, so you only need to test M4 weapons. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we will create the sound component and the particle effects component of the weapon object related functions. Open Atom Weapon. Create an audio component in Skeletal Mesh. Use it to play the fire sound. Create a function named playFireSound. This function is used to play the sound of the weapon firing. Call this function when the weapon fires. The weapon fires will be made in the weapon item object. So set this function to be category private. Each weapon has 2 firing sounds, one normal sound and one sound of the weapon firing with the silencer installed. So you need to determine if the current weapon has a silencer installed or not. First, determine if the model accessories object is empty. If the model object is not empty, get the model data through the model object. Determine whether the sound is silencer or not. Hide the variables that are not used. If it is a silencer, then use the silencer sound. If not silencer, use the default sound. Hide variables that are not used. If no model is currently installed, use the default sound. Finally, play the sound. The fire and sound function is now complete. Compile and save. Next, test that the sound is playing correctly. Open my character. When the 2 key is pressed, call the weapon object's play firing sound function. Run the game. Press the 1 key to generate the weapon. Press the 2 key. The current model is not a silencer, and place the default firing sound. Press the 3 key, and then press the 3 key again. Press 2. The current model is a silencer, and the firing sound with a silencer is played. Modify the weapon ID to 2. Run the game. Press key 1 to generate the weapon. Press key 2 to play the default firing sound. Press button 3 to change to silencer. Press 2 to play the firing sound with silencer. Modify the weapon ID to 3. Run the game. Press 1 to generate the weapon. Press 2 to play the default firing sound. Press 3 to change to silencer. Press 2 to play the firing sound with silencer. Next, make and play the fire particle effect function. Go back to Atom Weapon. Create a particle system component in skeletal mesh. Name it Fire Flash. This is used to create a flash particle effect when the weapon is fired. Set the particle effect to P weapon fired. Currently, all weapons use this particle effect when they fire, so just set it here. If you want different fire particle effects for different weapons, you can put the particle effects in the weapon data table. Set the auto activation to false. This will prevent the particle effect from playing when the weapon is created. Go back to construction script. When the weapon is fired, the flash effect is displayed in the muzzle. So you need to bend the firing flash effect to the muzzle of the gun. Add attach to component node. Target connect to fire flash. Parent connect to skeletal mesh. Set the socket name to socket muzzle. Set the rule of location to snap to target. Set the rule of rotation rule to keep word. Add comment. Compile, save. Create a function named play firing flash. This function is used to play the weapon firing particle effect. Call this function when the weapon fires, and the weapon fires will be made in the weapon item object. So set this function to be category private. If the weapon has a flash muzzle installed, the particle effect will not be shown when the weapon is fired. So you need to determine if the current weapon has a flash muzzle installed. If the muzzle accessories object is empty, then you need to determine if the muzzle object is empty. If the muzzle object is not empty, get the muzzle data through the muzzle object. Hide the variables that are not used. If it's not a flash, then play the fire particle effect. You only need to activate the particle effect once to play the particle effect once. If the weapon is not equipped with a muzzle, it will also play the particle effect. Compile and save. Next, test the fire particle effect. Open my character. After the firing sound, call the firing flash function. Run the game. Press 1. Create weapon. Press the 2 key. The particle effect shows up correctly in the muzzle position, but the effect is too large. Return to item weapon. Select Fire Flash and set scale to 0.3. Run the game. Press the 1 key, create weapon. Press the 2 key. This is now a more appropriate size. Press the 3 key. Switch to the flame gun mouth. Press 2. No particle effects are played. Save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making ammo item objects. Ammo is an item that can be stacked with amounts of bullets. When a character gets the same number of bullets, instead of creating bullet item objects repeatedly, the amount will be stacked on top of the existing bullet item object. Create an actor in Equipment and name it item ammo. Open. Click Class Settings. In the Details panel, set the parent class to item base. Open Construction Script. The ammo data in the ammo data table by ID. Save the ammo data to the object. named datas. Call the init function of the atom base class. Set the atom tab to ammo. Set the name of the atom by datas. Next, override the getObjectWeight function. Delete parent class node. You can get the weight of one round of ammo by the bullet data. Multiply the total number of bullets by the weight of one bullet to get the current ammo object weight. Compile. See you. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making equipment atom objects. Create an actor in equipment and name it atom equipment. Open it. Click Class Settings. In the Detail panel, set the parent class to atom base. In the Scenes component, create a static mesh component. It is used to display the equipment model. This model is only used for display and does not have any collision functionality. Set the collision procyte to no collision. Open construction script and initialize the equipment object in this. Get the equipment date in the equipment date table by ID. Save the data to the object named datas. Call the init function of the atom base class. Set the atom name and atom tab via datas. Head variables that are not used. Set the equipment model from the data. Compile, save. Next, test if the atom is displayed correctly. Open my character. Copy the Create Weapon node. Create an equipment object when the 7 key is pressed. Set the ID to 1. Run the game. The equipment displays correctly when the 7 key is pressed. Compile. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making atom objects that can be used. Currently, there are 2 types of objects that can be used: medicines and energy objects. Both of these atoms can be used with exactly the same logic. So, create a base class of atoms of type use and implement the common functionality in the base class. Create a new folder in the atoms folder and name it use. All the atoms objects that can be used will be placed in this folder. Create an actor in the use folder and name it atom use base. Open. Click Class Settings. In the Details panel, set the parent class to atom base. Add a variable named useTime. Tab float. Class settings is set to private. Indicates the time it takes to use the atom. This variable is set when the chilled class is initialized. compile, save, create an actor in use. Name it item health. Open, click class settings. In the detail panel, set the parent class to item use base. Open construction script. Get the data in the health data table by ID. Save the data to the object named datas. Call the init function of the item base class. Set the item type to health. Set the name of the item by datas. Set the useTime variable in the base class. Override to get the wait function. Use amount multiplied by. Get the weight of the item via datas. Compile, save. Create an actor in the use folder named item burst. Open. Click class settings. In the details panel, set the parent class to item use base. Open construction script. Get the data in the burst data table by ID. Save the data to the object named datas. Call the init function of the item base class. Set the item type to burst. Set the name of the item by datas. Set the useTime variable in the base class. Override to get the wait function. Use amount multiply get the weight of the item via datas. Compile, save. Object creation is complete. Specific use logic and health value recovery logic will continue to be completed later in the lesson. That is for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we'll make fashion item object. Create an actor in equipment and name it item fashion. Open it. Click class settings. In the details panel, set the parent class to item base. Open construction script and initialize the fashion object in this. Get the fashion data in the fashion data table by ID. Promote the data to a variable named datas. Save the fashion type to the object and name it function type. Call the init function of the atom base class. Set the atom type to fashion. Set the name of the atom. Compile, save. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. Starting in this lesson, we are going to make the atom generation feature. In this lesson, we'll start by looking at the rules for generating atoms. First, the atom on the floor will appear in groups. This atom group actor won't be used actually to display the atom object. This actor is used to indicate the location of the atom to generate the atom object. The number of atoms is random first. The number of atoms is 3 to 5. Then random atom types. Each type has its own change of occurrence. Atom types cannot be repeated. If they are repeated, they are re-randomized specific atoms of that type by atom type. If a weapon is randomized, the corresponding bullets are generated directly, and a fixed stack of bullets is generated. After generating additional ammo, remove the first atom that is not a weapon. An atom group can have up to 5 display positions, with 1 display position randomized. The position cannot be duplicated in an atom group. Finally, generate the atom object and then display it based on the location. This is the rule for atom generation. Next, explain the random algorithm. Take the random number of atoms as an example. The probability of a random number of 3 is 30%. The probability of a random number of 4 is 40%. The probability of a random number of 5 is 30%. First, create an array. Place 30 threes into the array. Place 44s into the array. Place 35s into the array. Then randomize an integer from 0 to 99. Use the random integer to get the final value from the array via getIndex. All other randoms use this method. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about making probability-related data tables. First, make the atom number probability data table. Open the Data's Table Structure folder and create a folder named Atom Generation. Create a structure and name it ST number probability. Open. The variable is named %. Type integer. Indicates the percentage of random 2. Create a new variable named number. Type integer. Indicates the number of atoms. Save. Close. In the data table folder, create a folder named Atom Generation. Create a data table. Select ST number probability. Name it DT number probability. Open. Add the data. Set the percentage to 30 and the number to 3. This means there is a 30% probability that 3 atoms will appear at random. Add data. Set the percentage to 40 and the number to 4. This means there is a 40% probability that 4 items will appear at random. Add data. Set the percentage to 30 and the number to 5. This means there is a 30% probability that 5 items will appear at random. Note that all percentages should add up to 100. Save and close. Next, make the item tab probability date table. Create a structure in the item generation folder and name it st-item tab probability. Open. The variable is named %, and the type is integer. Indicates the percentage of random 2. Create a new variable named type. Type e-item tab indicates the item type. Save, close. In the item generation folder, create a date table. Select st-item tab probability. And name it dt-item tab probability. Open. Add data. Set the percentage to 20 and the type to weapon. Indicates that there is a 20% probability of a random weapon. Add data. Set the percentage to 30 and the type to weapon accessories. Add data. Set the percentage to 10 and the type to ammo. Add data. Set the percentage to 8 and the type to health. Add data. Set the percentage to 10 and the type to burst. Add data. Set the percentage to 7 and the type to backpack. Add data. Set the percentage to 5 and the type to helmet. Add data. Set the percentage to 5 and the type to vest. Add data. Set the percentage to 5 and the type to fashion. Note that all percentages should add up to 100. Save and close. Next, make a single item probability date table. You don't need to create a new date table for the individual item probability. Just add a field to each item date table to represent the probability. Open the weapon date table structure. Create a new variable named probability %. Of type integer. Indicates the percentage of random probability for this item. Save and close. Open the weapon date table. Set the probability of M4 to 40, which means that M4 has a 40% probability of occurring. Set the probability of the AK to 40. Set the probability of the AWM to 20. The probability of all weapons should add up to 100. Save, close. Open the weapon accessories date table. There are currently 17 weapon accessories, and by default, they have the same random probability. So, there is not need to set a percentage for each weapon accessories. Close. Open the ammo date table structure. Create a new variable named probability %. Type integer. Indicates the percentage of random probability for this atom. Save. Close. Open the ammo date table. Set the 5.56 mm bullet probability to 80%. Since there is an 80% probability that a weapon using 5.56 mm bullets will randomly come out, set the probability of 7.62 mm bullets to 20%. Save. Close. Open the health date table structure. Create a new variable named probability percent. Type integer. Indicates the percentage of random probability for this atom. Save. Close. Open the health date table. Set the probability of the first aid kit appearing to 70%. Set the probability of the medical kit appearing to 30%. Save. Close. Open the burst date table structure. Create a new variable named probability percent. Type integer. Indicates the percentage of random probability for this atom. Save. Close. Open the burst date table. Set the probability of the energy drink to 40%. Set the probability of the painkiller to 30%. Set the probability of the adrenaline syringe to 20%. Save. Close. Open the equipment date table structure. Create a new variable named probability percent. Type integer. Indicates the percentage of random probability for this atom. Save. Close. Open the equipment date table. Note here that helmets, vests, and pigbags are counted separately when the tab is random, so the atom probability for each tab should add up to 100 here. Set Level 1 helmet to 50%. Set Level 2 helmet to 40%. Set Level 3 helmet to 10%. Set Level 1 vest to 50%. Set Level 2 vest to 40%. Set Level 3 vest to 10%. Set Level 1 backpack to 50%. Set Level 2 backpack to 40%. Set Level 3 backpack to 10%. Save. Close. Open the fashion date table. There are currently 8 fashions, and by default, they have the same random probability. So there is no need to set a percentage for each fashion. Close. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to create an atom group. First, create an atom group actor. Open the blueprint atoms folder. Create an actor object and name it atom group. Open. Create a scenes component. Replaces the default scenes component. An atom group can generate up to 5 items, so add 5 static mesh components under the same component. These 5 static mesh components are used to record the location. To see the effect better, and this foil static match to the atom model display, set all of them to weapon models. Since the weapon model is the largest, if all 5 weapons don't overlap, the other atoms won't overlap either. To see the effect better, add a temporary plane under the same component. Set the scale to 5. Then, adjust the position to try to ensure that each atom doesn't overlap. Delete the plane component. Compile, save. These 5 positions will be used when generating the atom object. So next, create a function that will be used to get the transform of the positions. Add a function, name it getAllTransform. Set the category to public. Set it to peer function. Add a return parameter named transform. Type array of transform. Make an array. Add 4 elements. Set the file model transform to the array respectively. It is important to note that you must get the transform of the model relative to the world, as it is created into the level when creating the atom object. Compile, save. Open the level. Next, place the atom group in the level and record the location of the atom group in the level. Drag and drop the atom group actor into the level. Here, you can drag and drop as many atoms as you like and as many locations as you like. Be careful not to let the atom group fit perfectly on the ground, as the ground may be uneven. When making the pick-up objects earlier, the pick-up objects are physically simulated and automatically fall to the ground after creating. Next, recruit these locations to the date table. Create a structure in the blueprint data's type structure atoms folder and name it st atom group location. Open. Set the first variable name to location. Type vector. used to indicate location. Save, close. Create a datetable in the datetable items folder. And select st item group location. Name it dt item group location. Open. Add a row of data. Open the level and add the location of all the item groups to the data table. You can quickly populate this by copying and pasting. Save and close. Next, delete all the test content. First, delete all the item groups in the level. Later, it will be created by dynamically generating them. Save the level. Open the item group. Set the model for all static mesh components to empty. When creating the items later, this item group actor will be spawned into the level as it needs to coordinates of each static mesh position relative to the world, in order not to affect the collision of the items. Here, you need to set the collision property of all static mesh to no collision. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. We will start this lesson by making the generate item object feature. Item generation is a rule of the game, so it should be implemented in game mode. Open my game mode. Add a function and name it generate items. Set the category to generate items. Used to generate items. First, loop through the item group date table. Create the get date table row names node. Select the item group location date table. The purpose of this node is to get all the row name fields in the date table. Loop through all row name. Get each item group location information in the date table by row name. Add comment. Loop spawn item group actor. Create a transform that uses the date obtained in the date table to set the location. Save the created item group object to a local variable named item group ref. This item group actor will use to record the location without any displayed model. Add comment. Randomize this atom group atom number first. Add function named random atom number and category as generate atom. Used to randomize the number of atoms. Add a return parameter named number of type integer. Indicates the random number value. Create the getDateTable row names node. Select the number probability date table. The purpose of this node is to get all the row name fields in the date table. Loop through all row name. Get the probability value for each number in the date table by row name. Create an array of local variables named ARR of type integer. Create the for loop node, starting from 1 and looping to the probability value. Each loop puts the corresponding number value into the array. Open the number probability table. There are 30 threes, 40 fours, and 30 files in this ARR array. After the array is filled, call the random integer in range node. The purpose of this node is to randomize a number of type int in a range. Min is the minimum value that can be randomized to, and max is the maximum value that can be randomized to. Set the minimum value to 0 and the maximum value to 99. The minimum value represents the ARR array's first index position, and the maximum value represents the last indexed position of the ARR array. The corresponding number value in the ARR array is obtained from the randomly selected index position. This number of values is returned. For more randomness, call the shuffle node of the array. After calling the shuffle node, the contents of the array are randomly distributed in order. To ensure that this logic is correct, we need to check that the created array contents are correct. Add a local variable named 3 of type integer. Add a local variable named 4 of type integer. Add a local variable named 5 type integer. Represent the number of 3, 4, and 5 in the ARR array, respectively. After the contents of the array are distributed in order, loop through the array. Determine that if the value is 3, the 3 variable is plus 1. Determine if the value is 4, then the 4 variable is plus 1. Determine if the value is 5, then the variable 5 plus 1. When the loop is complete, print the number 3, 4, and 5. Open event begin play. Call the random item number function. Run the game. There are 33s, 44s, and 35s in the array, proving that the array contents are correct. Delete the call. Delete the test variable. Delete the test node. Connect to return. Returns to the generate items function. Call the random item number function. Randomize list number of items. Add comment. Next, test if the number is correct. Add the print node after the random number and set the display duration to 500. Print the random number of items. Open event graph. Call the generate items function. Run the game. First, print a total of 12 times, matching the number of item groups. We have a total of 12. The minimum number of random items in each group is 3, and the maximum number is 5. Delete the test-related node. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson makes random item type logic. Open the level blueprint and delete the test node. Compile, save, close. Open my game mode. Add function, name it random item type. And category it generate items. Add return parameter, named item type. Type E item type indicates the random out item type. Create the get date table row names node. Select the item type probability date table. Loop through all row names. Get the probability value for each time in the date table by row name. Create an array of local variables named ARR of type E item type. Create the for loop node, starting from 1 and looping to the probability value. Loop through to put the corresponding amount of values into the array. Open the item type probability table. At this point, this ARR array has 20 weapon types, 30 weapon accessories types, 10 ammo types, 8 health types, 10 burst types, 7 backpack types, 5 helmet types, 5 vest types, and 5 fashion types. After the array is filled, call the random integer in range node. Set the minimum value to 0 and the maximum value to 99. Get the corresponding item tab in the array by the random out index position. Return this tab value. Returns to the generate items function. Calls the random item tab function. Open the random item tab function. To ensure that this logic is correct, we need to check that the created array contents are correct. After the array is filled, loop through the array. Print the contents of array. Print the logo after loop completes. Connect the return node. Compile, save. Open event graph. Call the generate items function. Run the game. Open the output window. Check against it that the number of each tab in the array is correct. Without wasting time here, the number in the array is correct to improve the random realism. Call the shuffle node of the array before returning. Delete the test node. Compile, save. Open the generate items function. In an item group, there cannot be the same item tab. So here, you need to determine if the item tabs are duplicated. Add a local variable named items tab ARR. An array of tab item tab. It is used to store the randomly selected item tabs. Find the item tab in the array. Determine if the result of the search is equal to -1. If it is not equal to -1, then prove that the tab is duplicated. If the tab is duplicated, re-randomize the item tab. If it is equal to -1, prove that the same type was not found. If there is no duplicate, then add to the array. Add comment. Add comment. Compile, save. Next, test if the item tab is correct. After the random item tab is complete, loop through the item tab array. Print the item tab. Set the duration to 500. For easy viewing, print a line of markers after the loop completes. Set the duration to 500. Clear the item tab array. Run the game. The item tabs in each item group are not duplicated. Delete the test node. Compile. Save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, make random item ID logic. Open my game mode. Random item ID by item tab. Add function named random item ID, and the category is generate items. Use for random item IDs. Add input parameter named item tab. Tab item tab indicates the item tab. This function needs to return the item ID and return the tab of item the ID belongs to. A struct needs to be created. Create a structure in datas, table structure, item generation, named st items tab and ID. Open. Set the variable name to tab and the tab to item tab. Indicate the item tab. Create a new variable named ID. Tab name indicates the item ID. Save, close. Return to my game mode. Add a return parameter named item. Tab st item tab and ID. Create the sequence node. Different item tabs. Use different date tables for switch item tabs. In case of weapon tab, create get date table row names node. Select the date table as the weapon date table. Iterate through all row names. Get the weapon variables in the date table by row name. Expand structure and keep only probability variables. Create an array of local variables named ARR of tab st item tab and ID. Loop through to place the corresponding number of weapons into the array. Create a structure. Set row name to ID. If it is a weapon accessories, the whole process is the same. Copy. Change the date table to weapon accessories date table. The probability is the same for all weapon accessories, so add each weapon accessories directly to the array. Set Structures tab to Weapon Accessories. In the case of ammo, the whole process is the same. Copy. Change the date table to the ammo date table. Re-expand the ammo data structure to keep only the probability variables, and set the probability to loop. Set Structures tab to ammo. If it's a health, the whole process is the same. Copy. Change the date table to health date table. Re-expand the health date structure. Keep only the probability variable and set the probability to loop. Set Structures tab to Health. If it's burst, the whole process is the same. Copy. Change the date table to the burst date table. Re-expand the burst date structure, keeping only the probability variable and setting the probability to loop. Set Structures tab to burst. If it's helmet, the whole process is the same. Copy. Change the date table to the equipment date table. Re-expand the equipment date structure. Keep the tab and probability variable and set the probability to loop. Set the Structures tab to Helmet. Since the equipment date table includes 3 types of equipment, determine if it is a helmet before executing the loop. If it's a vest, the whole process is the same. Copy. Determine that it is changed to vest. Set Structures tab to vest. If it is a backpack, the whole process is the same. Copy. Adjust to change to backpack. Set Structures tab to backpack. If fashion, copy the follow of weapon accessories. Change the date table to fashion date table. Set Structures tab to fashion. Note here that fashion's ID 1 and 4 are the default undergarments. The default underwear is not available. So you need to determine if the number 1 or 4 is not placed in the array. The array is now ready. The next step is to start performing random operation. Call the random integer in range node. Since the contents of the arrays of weapon parts and fashion are not 100, you need to randomize them according to the number of arrays. Set the minimum value to 0, which represents the first element of the array. Set the maximum value to the length of the array minus 1. Get the corresponding data in the ARR array by the random out index position. Return this data to improve the realism of the random. Call the shuffle node of the array before returning it. Compile, save. Return to generate items. Loop the item tab array after randomizing the item tabs. Create an array of local variable named items ID ARR. Tab st item tab and ID. Call the random item ID function. Add the randomly selected items to the array. Add comment. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. In this lesson, we are going to continue making logic for generating items. If a weapon is randomly created in an item group, then ammo corresponding to that weapon needs to be generated in that item group. In this lesson, we will add the ammo logic for the weapon. Open the generate items function of my game mode. After randomizing the item ID, clear the contents of the item tab array so that it is correct when the next item group starts randomizing. Next, you need to check if there are any weapon tab items, and if there are, then the corresponding ammo tab is automatically correct. Loop through the item number array to check if there is a weapon. If a weapon is present, add an ammo item to the item ID array. Find the ammo ID used for this weapon in the weapon date table by the weapon ID. Cite the ammo ID. An additional ammo item is added, and a non-weapon item needs to be removed. Loop the item ID array. Delete the first item, that is not a weapon. Each group of items will generate at most one weapon item, so only one item needs to be deleted. Deleting ends the loop. Add comment. Add comment. Add comment. Add comment. Next, test if the corresponding ammo is generated correctly. After the ammo is generated, loop through the item ID array. Print the item information. When the loop is complete, print the mark and empty the item ID array. Run the game. You can see that if there is a weapon in the item group, there will be ammo corresponding to that weapon, and the total number of items in each item group will not exceed the limit. Delete the test node. Compile. Save. That is for this lesson. Thanks for watching, and we'll see you next lesson. The item generation. After finding the weapon is complete, loop the array of item numbers. Save the item tab as a local variable, named spawn type. Save the item ID as a local variable, named spawn ID. Add the sequence node. Once the loops are complete, all the items in the current item group will be generated, so empty the item array. Add comment. Next, random locations. Each item group can have up to 5 locations. Create one random position at a time. Add function named random location and category as generate items, used to display the location randomly. Add input parameter named available. Tab transforms array. This is used to indicate the location that is available. Add a return parameter named location. Tab transform indicates a randomly selected location. Add the random integer in range node. Set the maximum value to the length of the available array minus 1. Get the location value from the available array. And return. Compile, save, return to generate items. Call random location function. To get all available locations from the item group object. Set. Create a local variable named used locations. Tab transform array, used to represent an array of already used locations. Look for randomized locations in the already used locations array. If found, the locations needs to be randomized again. If not found, save the cost location variable, named spawn location. Add to the array of already used locations. Add comment. Compile, save. Next, test the generated location for repeats. Print the randomized out locations when the location randomization is complete. Print the marks after each item group randomization is complete. Run the game. By printing the values, you can see that each item group's positions are not repeated. Delete the test node. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. The previous lesson have done all the preparation for generating items. In this lesson, we will going to generate the item actor finally. Each generated item needs to have a unique identifier that will not be repeated throughout the game. Open my game instance. Open the full blueprint. Add a function named generate_sn, category public. It is used to generate an SN. Turn this function into a pure function, since it only needs to get the return value directly. Add a return variable named SN of type string. Random two numbers of type float. splice the two numbers into a string. Set to the return value. Compile, save. Open the event graph for MyGame mode. Get the game instance. Convert it to MyGame instance. Promote to variable, named MyGame instance ref. Open the generate items function. Add a local variable named items object. Tap pick up base to the array, used to store the item objects created in this function. Switch item type. Add spawn actor node. If it's a weapon, set class type to pick up weapon. Set transform. Set ID. Call generate SN via game instance to set SN. Set amount to 1. Add the weapon object to items object. Duplicate node. Recreate the spawn actor node. Connect the weapon accessories. Set pickup class to pick up weapon ACC. Connect location, number, SN. Set number to 1. Connections are added to the array. Duplicate node. Recreate the spawn actor node. Set pickup class to pick up ammo. Connect the ammo. Connect location, number, SN, number to 0. Connections are added to the array. Duplicate node. Recreate the spawn actor node. Set pickup class to pick up health. Connect health. Connect location, number, SN. Set number to 1. Connections are added to the array. Duplicate node. Recreate the spawn actor node. Set pickup class to pickup burst. Connect burst. Connect location, number, SN. Set number to 1. Connections are added to the array. Duplicate node. Recreate the spawn actor node. Set pickup class to pickup equipment. Connect fashion. Connect location, number, SN. Set number to 1. Connections are added to the array. Duplicate node. Connect fashion. Recreate the spawn actor node. Set pickup class to pickup fashion. Connect location, number, SN. Set number to 1. Connections added to array. Add comment. Compile, save. Run the game. As you can see, all items are generated on the ground according to our random algorithm. At this point, all the functionality of the atom generate system is complete. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, We'll look at where all the data that needs to be persisted should be stored. I'm not going to explain every variable and every function in great detail in this lesson, but I will do so later in the cross creation process. In this lesson, we will start with an understanding of the entire data storage architecture. Just because I don't write input and output agreements for all functions doesn't mean that all functions don't have input or output agreement. In this lesson, we only need to understand the function's basic functions, and the specific input and output parameters will be explained in details later in the lesson. The game mode mainly performs some logic related to the rules of the game. The generate items function is used to generate all the scenes items at the beginning of a game. Game state stores state related to a game's state. The line amount is the number of players alive in the current game. The player controller is responsible for all players' behavior logic. There are two arrays of items related to this. Pick up items stores all items on the ground that can be picked up. This array is initialized at the start of the game. During the game, the player's pickups and throws will dynamically modify this array. Items in scope stores items that are currently in the player's pickup range. The player can pick up the items in this array by pressing the F key or through the UI. Player state stores all data related to the current player's state. There are three categories of data. The first category is the item class. Weapon 1 is the weapon object on the left side of the current character's bike. Weapon 2 is the weapon object on the right side of the character's bike. Hold gun represents the weapon object currently held by the character. Note that the above three variables can have up to two objects that are not empty at the same time. For example, if a weapon is placed in the hand from the left side of the character's back, the weapon object will be saved in the hold gun variable, and the weapon 1 object will be empty. In this weapon object, it will be recorded whether the weapon was placed in the hand from the left or right side of the back. Ammo 556 indicates the number of 5.56 mm rounds in the character's backpack. Ammo 762 indicates the number of 7.62 mm rounds in the character's backpack. Note that even if the character doesn't have a backpack equipped, the character has a default capacity for storing items. Equipment stores all currently worn equipment objects. This includes helmet, vest, and backpack. Fashions stores all the fashion objects the character is currently wearing. Items in backpack stores all items objects currently in the character's backpack. These include weapon accessories, ammo, health, and burst. The second type of data is the character's data. Health point represent the current character's life value. Energy point represent the current character's energy level. The third type of data is record-related data. Killed amount represents the value of the number of other characters the current player has killed. All variables in this category are private and cannot be called directly. All non-array type variables have a corresponding get or set function. There are many benefits of getter and setter. In our game, the biggest benefit is that when a variable is modified, an event is sent once in setter, and all the plays listening for this event are notified, and then the logic is processed accordingly. The other thing is that when we have a lot of code, the variables are called from many places, and using the getter function, we can quickly find out where they are called. Variables of the array type have corresponding functions for adding and moving array elements. This has the same benefits as getter and setter for variables. Some functions deal with pure state functions, which are placed in player state because they deal with data-related logic. There are two functions related to the backpack function. The check backpack capacity function is used to check if the backpack capacity is enough, and this function is called when adding items to the backpack. The check replace backpack function is used to check if there is enough capacity in the backpack when replacing it. The update ammo object function is used to update the ammo object based on the number of bullets when bullets change. The update weapon ACC function is used to update the data and display of a weapon accessories and is called a change in the weapon accessories. Game instance stores all the constants. What are constants? Constants are values that do not change during the round of the game. All variables starting with gun indicate the name of the socket the weapon is in the character's hand. Sockets are different for different states of the character. Variables starting with back indicate the name of the socket on the back of the character's weapon. There are sockets with and without a backpack. Helmet name indicates the socket's name in which the helmet model is attached to the character's skeleton. Vest name indicates the name of the socket where the vest model is attached to the character's bones. Backpack name indicates the name of the socket where the backpack model is attached to the character's skeleton. These sockets will be explained in detail in later lessons. Default capacity means the default capacity of the backpack. If the character doesn't have a backpack, generate SN function is used to create a unique identity. It's used when creating items. These are the data that needs to be stored during the game run. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create data-related variables. Open my game state. Open the for blueprint. Create the variable named live amount. Type integer. This is used to indicate the current number of ruler remaining. Compile, save, close. Open my player controller. Create a variable named pick up items of type pick up base array. Category is items. This is used to save all pick up items objects. Create a variable named items in range of type pick up base array. Category as items, used to save all item objects that enter the character's range. Compile, save, close. Open my player state. Create variable named weapon1. Type item weapon. Category as items. Set variable to private. It is used to represent the weapon equipped to the left side of the character's back. Duplicate the variable. Name it weapon2. Used to represent the weapon equipped to the right side of the character's back. Duplicate variable named hold gun. Category items indicates the weapon the character is holding. Create variable named ammo 556. Type integer. Category items set variable to private, used to represent the total number of 556 bullets currently in the backpack. Duplicate variable named ammo 762 represents the total number of 762 bullets in the current backpack. Create a variable named equipment of type item base array. Category as items and set the variable to private. It is used to indicate the equipment the character is currently wearing. Duplicate variable named fashions, used to represent the fashions the character is currently wearing. Duplicate variable named items in backpack. represent all the items in the current backpack. Create a variable named health point. Type float. Category character. And set the variable to private, used to represent the current character life value. Set the default value to 100. Duplicate variable named energy point, used to indicate the current character energy value. Duplicate variable named killed amount. Category record. Type is integer. It is used to indicate how many other players the current player has defeated. Next, make the getter function. Add the function named getWeapon1. And category as getter. Since you only need to get the return value directly, make this function a pure function. Add the return parameter, named weapon. Type item weapon. Return the weapon1 object. Duplicate the function and name it getWeapon2. Return the weapon2 object. Duplicate the function. Name it getWholeGun. Return to the holdgun object. Duplicate the function. Name it getAmmo556. Return the parameter named amount. Type integer. Return the ammo556 variable. Duplicate the function named getAmmo762. Return the ammo762 variable. Duplicate the function named getHealthPoint. Return the parameter named value. Type float. Returns the health point variable. Duplicate the function named getEnergyPoint. Returns the energy points object. Duplicate function named getEquipment. Return parameter named equipment. Type item base object array. Set variable. Duplicate the function named getFashions. The return parameter is named fashions. Set variable. Duplicate the function named getItems. The return parameter is named items. Set variable. Next, make the setter function. Add the function named setWeapon1. Category setter. Add the input parameter named weapon. Tap item weapon. Set the weapon1 variable. Add an event named event weapon changed. Add parameter named weapon. Tap item weapon. Indicates the changed weapon object. Add parameter named position. Of type E weapon position. Indicates the changed position. Add a parameter named is on hand. Of type boolean. Indicates if it is on hand. Send a weapon change event. Set the weapon object. Set the position to left. Set not on hand. Duplicate function named setWeapon2. Set weapon2 variable. Select the weapon position in the event to the right. Duplicate the function named setHoldGun. Set holdgun variable. Get the current weapon location from the weapon object and set it. Set in hand. Determine if the object is valid. If valid, you can set the position via the weapon object. If not valid, do not set the location. Duplicate the function named setAmmo556. The input parameter is named value. Tab integer. Set ammo556 variable. Delete the event node. Add an event named event ammo changed. Indicates a bullet change event. Send a bullet change event. Duplicate function named setHealthPoint. Set tab to float. Set healthport variable. Delete the send event node. Add an event named event healthport changed. Add a parameter named value, tab float. Compile. Call the event. Set the health point. Duplicate function named setEnergyPoint. SetEnergyPoint variable. Delete the send event node. Add an event named event energy point changed. Add a parameter named value, tab float. Compile. Call the event. Set the energy value. Add a function named addEquipment. Category array add. Add input parameter named equipment. Tap atom base. Add to array. Add an event named event equipment changed. Add a parameter named equipment. Tap atom base. Add a parameter named isAdd. Tap boolean. Indicates whether or not the equipment is added. Send event. Set the equipment object. Check yes to add. Duplicate function named addFashion. The parameter is named fashion. Set variable. Delete event. Add an event named event fashions changed. Add a parameter named fashion. Tap atom base. Add a parameter named isAdd. Tap boolean. Indicates whether or not the fashion is added. Send event. Set the array of fashion objects. Check yes to add. Duplicate function named addAtom. The parameter name is atom. Set the object array of the atom. Delete event. Determines whether the atom tab is a health or is a health. If yes, loop the atom array. Determine the atom tab and whether it matches the tab of the atom to be added. Then determine the atom number of the atom to be added. If the atom number is the same as the atom number, if both match, use the current atom number. Add the array of atoms to be added. Set to the current number of atoms. Add a local variable named isFound. Indicates if items of the same type are found. Set to true. Add an event, name it event items changed. Add a parameter named item of type item base. Add a parameter named isAdd. Type boolean indicates whether or not the item is added. Send event. Set the item update to the current item. Check yes to add the item. End the loop. Add comment. When the loop is complete, determine if it was found. If not found, add the item object to be added to the item array. Send event. If it is not a health or burst, and it directly to the item array. Add comment. Duplicate the function. Name it remove equipment. And category it array remove. Add a return parameter named remove. Type boolean. Compile. Remove objects in the array. Uncheck add equipment. Return. Duplicate the function named setAmmo762. Set ammo762 variable. Duplicate the function named remove fashion. Input parameter named fashion. Delete the object in the array. Send the fashion change event. Duplicate the function and name it removeAtom. The parameter is named atom. Delete the object in the array. Send the atom change event. Compile, save, close. Open my game instance. Create variable named default capacity. Type integer. Category is backpack. Indicates the amount of atom storage the character has when not equipped with a backpack. Compile and set the default value to 50. Set to read-only variable. Create a variable named gunStandName. Type name. Category socket name weapon. Set to read only. Use this socket when the character stands with a gun, jumps, transition animations, equips a weapon, unload a weapon, and dies. Set the default value to socket gun stand. Create a variable named gunAimName. Of type name, category socket name weapon, set to read only. Used to indicate the name of the weapon's socket when the character is aiming with a gun, and set the default value to socket gunAim. Duplicate variable named gunReloadName indicates the socket's name for the weapon when the character changes magazines or bullets with the gun, and set the default value to socket gun reload. Duplicate the variable named gunProne idle name indicates the name of the weapon's socket when the character is prone in standby and firing. Compile and set the default value to socket gun prone idle. Duplicate the variable and name it gunProneFBName. Indicates the weapon socket's name when the character is moving forward or backward with the gun in the prone position. Compile and set the default value to socket gun ProneFB. Duplicate the variable and name it gunProneOtherName. Indicates the weapon socket's name if the other moves in the other direction with the gun prone. Compile and set the default value to socket gun ProneOther. Duplicate the variable and name it gunCrouchName. Indicates the name of the weapon socket when the character is in a gun crouch. Compile and set the default value to socket gun crouch. Duplicate the variable named backLeftName. Name of the weapon socket on the left side of the back when the character is not equipped with a backpack. Compile and set the default value to socket backLeftNormal. Duplicate the variable and name it backRedName. Used to indicate the red weapon socket's name on the character's back when the character does not have a backpack equipped. Compile and set the default value to socket backRedNormal. Duplicate the variable named backLeftBName. Name of the weapon socket on the left side of the character's back when the character has a backpack equipped. Compile and set the default value to socket backLeftBackpack. Duplicate variable named backRedBName. Used to represent the name of of the weapon socket the character is holding. Compile. Set the default value to socket back red backpack. Duplicate the variable named helmet name. Category is socket name equipment, used to represent the name of the character's helmet socket. Compile and set the default value to socket helmet. Duplicate the variable named vest name, used to represent the name of the character's vest socket. Compile and set the default value to socket vest. Duplicate the variable name backpack name, used to represent the character backpack socket name. Compile, set the default value to socket backpack. The socket's specific character. Hello everyone, I'm Big Cat. Start in this lesson, we will be making pick-up items, throw items, and item replacement related features that may result from picking up items. The items include equipment and weapons, and changes to equipment and weapons will result in changes to the character display. That is, the equipment and weapon custom change display function. When a character picks up weapons and equipment, they need to be displayed on the character. This is different from the way fashion is displayed. First, a corresponding weapon or equipment actor will be created. This actor is responsible for displaying the model. This actor is the item object that we talked about in the previous lesson. Then this actor will be inserted into the character by way of sockets. So, it will be accessories to create the corresponding sockets in the character's skeleton for display. This lesson creates the sockets you need in your character's skeleton. Open the character skeleton file. First, make the weapon socket. There are 3 weapon sockets: the holding position, the left back position, and the right back position. Since our character animations are not uniformly created, we may need to use different sockets for different character animations, so there may be multiple sockets for the same position. Socket gun aim indicates the position of the weapon when the gun is held and aimed. Add a prevail resource. Click Prevail Animation to select a prevail animation. Select the gun aimed standby animation. The character in the window starts playing the animation. The animation we select here will have no effect on the running game and will only be used as a preview. I have adjusted the position and the rotation of the socket beforehand. Set the prevail animation to AS rifle, aim, stand, walk, forward. Displayed correctly. Set the prevail animation to AS rifle, aim, crouch, walk, forward. Displayed correctly. Set the prevail animation to AS rifle, stand, fire. Displayed correctly. Set the prevail animation to AS rifle, crouch, fire. Displayed correctly. This socket is used when the character state is for all aiming actions except prone. This socket is also used for all fire animations other than prone. Socket gun prone idle is the socket used when the character is in standby with a gun prone. Delete prevail resources. Add prevail resources. Set the prevail animation to AS rifle prone idle. Display correctly. Set the prevail animation to AS rifle prone fire. Displayed correctly. Socket gun prone FB is used when moving forward or backward with the gun in prone. Add prevail resource. Set the prevail animation to AS rifle prone walk forward. displayed correctly. Use this socket when the character is moving forward or backward while prone. Socket gun prone other is the socket used when the gun is prone and moving in the other direction. Delete the previous resource. Add a previous resource. Set the previous animation to AS rifle prone work left backward. Displayed correctly. Use this socket by moving the gun in the other direction while holding it in a prone position. I'm sorry, but I can't find a better animation for the gun prone, so I hope you forgive me, but it doesn't affect us to learn how to make the game. Socket gun reload is the weapon socket for changing magazines or bullets. Add the previous resource. Set the previous animation to AS stand reload. Displayed correctly. Socket gun stand is the socket used when holding a gun in a standing position. Delete the previous resource. Add the previous resource. The display here is not completely correct. Open the anime graph of my anime blueprint. In the previous lesson, animation blending was done while in gun stand, so we can't play a separate animation to see the effect, but we can see the final animation in the animation blueprint. Set aim offset tab to 3. Select the gun state. The animation is currently displayed correctly. Set the speed to 300. It was noted that the character's left hand is not holding the gun very well. Here is how to solve this problem by bounding IK. What is IK? First, take a look at the picture on the left. Most animated skeletons in Unreal are driven by direct rotational data fed straight into the bones of the character or skeletal mesh. This can be thought of as forward kinematics or direct application of rotation to joints or bones. Below is a diagram illustrating the concept. As its name implies, inverse kinematics works in the other direction. Instead of applying rotation to bones, we instead give the bone chain a target, providing a position that the chain's end should try to achieve. The user or animator moves the effector and the IK solver rotates the bones such that the final bone in the chain ends at the target location. In the image below, the end effector is designated by the red cross. That's the basic principle of IK. Next, let's see how to use the IK feature to implement keeping your hand on the gun. Add the two bone IK node. Connect the hold gun stand. Connect pulse 3. Compile. Select the two bone IK node. The effector is the skeletal property being referenced. Select the bone's space. Select the right hand bone. This indicates that the right hand bone will be referenced IK bone. Select the left hand bone. The left hand bone will be moved with reference to the right hand bone. Compile. Adjust the left hand to the correct position of the gun first. You can adjust the position by dragging and dropping. Here I have peer-adjusted a position. The positions are minus 25.06399, 8.06399, 2.533, 2.568. Then adjust the joint target position. This point affects the behavior of the associated skeleton. Set the position to 91.286 minus 88.835 17.989. The captor's left hand is now attached to the weapon. Set aim offset tab to 3. Set hold gun to true. Adjust the speed value to 300. The character moves with the left hand in the correct position, in addition to using this socket for standing with a gun. This socket is also used for jumping, transition animations, equipping a weapon, unloading a weapon, and death animations. Open the character skeletal file. Socket gun crouch is the socket used when holding a gun in a crouch position. Delete the previous resource. Add the previous resource. Open the animation blueprint. Set aim offset tab to 4. Select the gun state. Select the crouching position. Set the crouching position the same way you just set the standing AK. Copy and paste. Connect the gun crouch. Connect pause 4. Compile. Select the 2-bone AK node. Adjust the left hand to the correct position of the gun first. Set the positions to minus 29.431, 10.474, 0.982. Then adjust the joint target position. Set the position to 91.286 minus 88.835, 17.989. The captor's left hand is now affixed to the weapon. Set aim offset type to 4. Select the gun status. Select crouch position. Adjust the speed value to 300. Display correctly. Go back to the character skeletal file. Socket helmet is the equipment socket. Delete the previous resource. Add the previous resource. Socket vest is the vest socket. Add the vest model. Socket backpack denotes the backpack socket. Add the backpack model. Delete the model. No backpack back weapon socket. Socket back left normal is the weapon socket on the left side of the back when no backpack is equipped. Add weapon model. Socket back right normal is the weapon socket on the right side of the back when you don't have a backpack. Add a weapon model. Remove model. Socket back left backpack is the weapon socket on the left side of the back when equipping a backpack. Add a weapon model. Socket back right backpack is the weapon socket on the right side of the back when equipping a backpack. Add a weapon model. This completes the weapon and equipment related sockets in the character skeletal model. Save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I am Big Cat. In the last lesson, we made sockets for all weapons and equipment. In this lesson, we will use these sockets to display the corresponding weapons or equipment. Open my character. Since the character's weapons and equipment objects are stored in the player state, you need to create player state object reference. This is convenient for later logical use, aiding begin play event. Converts to my player state. Promote it to a variable named myPlayerStateRef. Some constants will be used later, so you need to create a game instance object reference, easy to use for logic later. Get the game instance object. Convert it to my game instance. Promote it to a variable named myGameInstanceRef. Add comment. Next, make a function to update the weapon display position. Add a function named updateWeaponDisplay. Category changing items. It is used to update the weapon display. Add an input parameter named holdSocket. Tab name. This is used to indicate the name of the handheld weapon socket. Update the display of the handheld weapon first. Aiding sequence node. Determine if the current handheld weapon is empty. Set the transform of the weapon object first. Call meshes getSocketTransform node. Since the handheld weapons sockets will change with pose and state, you need to calculate it when you call this function. Set the socket name. Then, attach the weapon to the mesh. Set the socket name. Set the row for location to snap to target, which means to attach the model to the target value. Set rotation rules rule to keep word, which means that the model's position stays the same as the word rotation. Set transform. This completes the update of the handheld weapon location. The two operations, setting transform and attach to mesh, will be repeated later. Turn them into a function named attach. Category changing items. Open the attach function. Add an input parameter named item of type item base object reference. Add the input parameter named socket name. Type name. Replace item. Replace socket name. Compile and save. Return to the update weapon display function. Set the socket name parameter. Before setting the handheld weapon socket, you need to determine the hold socket. If it is not set, the default value is none. If it is equal to none, then the update is not a handheld weapon. Add a comment. Next, update the back weapon display location. Add sequence node. The position of a character with and without an equipped backpack is different, so you need to determine if the current character has an equipped backpack. Add a local variable named isEquipBackpack. Tab boolean indicates if the backpack is equipped or not. Get only items that the current character has equipped via player state. Loop through. Determine if the item type is a backpack. If it is a backpack, set the equipBackpack variable to true. After the loop is complete, determine if there is a weapon on the left side of the character's back. If there is a weapon, determine if a backpack is equipped. Call attach function. If the backpack is equipped, set the socket name to BackLeftB name. If no backpack is equipped, set the socket name to BackLeft name. Next, update the back right weapon. Copy. Paste. Change weapon 1 to weapon 2. Change left B to right B. Change left N to right N. Add comment. Update weapon display logic is complete. Compile, save. Next, make a function to update the equipment display. Add a function named updateEquipmentDisplay. Category is changing items. It is used to update the equipment display. The equipment update is not affected by the character's current pose, nor is it affected by its current state. So the only direct display is needed. Get all the items that the character has equipped via player state. Loop through. For ease of use, promote the object to a local variable named item. Switch item tab. If it's a helmet, use the name of the helmet from game instance. Call attach function. Copy, paste. If it's a vest, use the name of the vest in the game instance. Copy, paste. If it's a backpack, use the backpack name from game instance. Note here that if a helmet is equipped, you need to hide the character hair. Add the sequence node. Add a local variable name has helmet, type boolean. Set the variable to true if a helmet is present. Determine if there is a helmet. If there is a helmet, hide the hair model. If there is not helmet, show the hair model. The logic for updating the equipment display is complete. Compile, save. Next, make update the fashion display function. Add a function named clear fashion. Category skeletal mesh. Clear all the fashions on the character and display them in the default state. Call the replace skeletal mesh function. The fashion tab is top. The ID is 0. When the ID is set to 0, it is automatically displayed as the default state. Copy, paste. Set the fashion tab to pants. Copy, paste. Set the fashion tab to hole. Copy, paste. Set the fashion tab to shoes. Compile, save. Add a function named update fashion display. Category is changing items. It is used to update the fashion display. Call clear fashion function first. Clear all fashions. Get all the fashion objects that the current character has on via player state. Loop through. Call the replace skeletal mesh function. Convert to item fashion tab. Set the fashion tab. Set the ID. Compile, save. These are the 3 items that need to be updated for display. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm BitCat. In the last lesson, we created functions related to updating the character display. In this lesson, we will make calls to these functions. Open my player controller. Since the sockets for handheld weapons change with pose and state, you need to calculate which socket to use for handheld weapons first. Add an object reference to MyGame instance during initialization. Get the game instance. Convert to MyGame instance. Promote to variable named MyGameInstanceRef. Add function named calculate hold gun socket. Category items socket. Add an output parameter named socket name, tab name. Check pure. Add a local variable named gun socket, tab name. First, determine if the current character is prone. If it is prone, get the value of access in forward or backward direction. It is equal to 0 and access in left or right direction is equal to 0. If yes, it means the character is not moving. Get the gun prone idle name from the game instance. Set to socket name. If no, prove that the character is moving. Determine if the move left or move right access value is 0. If it is 0, prove that it is current moving forward or backward. Get gun prone FB name from game instance, set to socket name. If it is not 0, it proves that it is moving in the other direction. Get gun prone other name from the game instance, set to socket name. Prone posture on these 3 cases. Add comment. If it's not prone, determine that it's crouched and not in aim. If yes, get gun crouch name from game instance. Set to socket name. Add comment. If no, determine if the current character is in aiming or firing state. If yes, get gun aim name from game instance. Set to socket name. Add a comment. If no, determine if the current character is in weapon change state or magazine and ammo change state. If yes, get gun reload name from game instance. Set to socket name. Add comment. If none of the above states, get gun stand name from game instance. Set to socket name. Add a comment. Add the sequence node. Add a return parameter named socket name. Return. Compile, save. Next, we start doing event listening. In player state, there are item-related change events. First, let's listen for events that will cause the character display to change. Add the sequence node to the event begin play event. Get player state. Convert to my player state. Promote to variable named my player state ref. Assign the weapon change event. Customize the event name to event weapon changed. Cause the update weapon display function in character and set the socket name. Assign the equipment changed event. The custom event is named event equipment changed. Then call the update weapon display. The main reason the update weapon display is called here is that it affects the character's backpack display position when a backpack is equipped or unpacked, and only the back weapon is affected. So, there is no need to call the calculate handheld weapon socket function. Assign fashion change event. The custom event is named event fashion changed. Call the update fashion display function in character. Add comment. For now, we will only use these three change events. The other change event will be created when they are used later. All montages will be notified with an event when they are played. Next, we listen to the event when the montage is finished. We get the animation blueprint object used by the current character from the character's mesh. Assign the montage played end event. Get the current playing montage animation. Determine if the montage is valid. If the montage is valid, it means there are still montages playing. If not, no more montages are playing. Set whether or not the montage is playing in character to false. Add a comment. A change in the character's state affects the sockets of the hold weapon. Flag the crouch input event. After executing the crouch key logic, call to calculate the held weapon's socket position, and then call the update weapon display function in my character. Friend the prong event. After executing the prong logic, calls the calculate handhold weapon socket position, and then calls the update weapon display function in my character. Add the aim input event. We'll do the simplest state change here. Set the character is aiming to true when pressed. Set the characters is aiming to false when released. Call the calculate handhold weapon socket position, and then call the update weapon display function in my character. Add comment. compile, save. Calls the calculate handheld weapon socket position and then the update weapon display function in my character when there is a forward or backward movement change. Calls to calculate the handheld weapon socket's position and then to update the weapon display function in my character when there is a left or right movement change. This is all that needs to be called to. Hello everyone, I'm Big Cat. In this lesson, we will test the logic of the previous lesson's costume changes to see if they are correctly. First, let's test the handheld weapon display. Open my character's event graph. Add the keypad 1 key event. Set the character's gun states to true. Spawn a weapon object. Set the ID to 1. Set the SN to 111. Set the amount to 1. Make transform. Set the object to hold gun in player state. Run the game. Press the 1 key. Test the standing pose first. Standby weapon is displayed correctly. Stand walk is displayed correctly. Standing drop is displayed correctly. Stand run displays correctly. Test the standing aim. Hold down the right mouse button. Move. Displayed correctly. Test crouch. Crouch standby is displayed correctly. Crouch walk is displayed correctly. Crouch jogging is displayed correctly. Crouch run is displayed correctly. Test crouch aim. Hold down the right mouse button. Move. Displayed correctly. Test prone. Prone idle is displayed correctly. Prone and move forward or backward is displayed correctly. Prone and move in the other direction is displayed correctly. Next, test the equip weapon and unload weapon animations. Add the keyboard 2 key event. Set the playing montage to true. Add the play montage animation node. Select the standing position to equip the weapon animation. Add keypad 3 key event. Copy and paste. Choose standing position to unload weapon animation. Run the game. Press keypad 1. Press keypad 2. The animation plays correctly. Press 3 key. The animation plays correctly. Modify to crouch to equip the weapon animation. Modified to crouch unload weapon animation. Run the game. Press 1. Switch to crouch. Press 2. The animation plays correctly. Press 3. The animation plays correctly. Modify the animation to prone and equip the weapon. Modify the animation to prone and unload the weapon. Press 1. Switch to prone. Press 2. The animation plays correctly. Press 3. The animation plays correctly. Next, test the magazine's change animation. Add the keypad 4 key event. Copy and paste. Select the standing magazine change animation. Set the magazine change state to true. Call the calculated handheld weapon socket and update weapon display functions. Add delay time. This is the time for the magazine change animation to play. After the animation is played, set the magazine change status to false. Then recalculate the handheld weapon socket position and update the weapon display. Run the game. Press the 1 key. Press the 4 key. The animation plays correctly. Switch to crouch position. Press the 4 key. The animation plays correctly. Modify the weapon animation to prone. Modify delay time to 2.4. Run the game. Press 1. Switch to prone. Press the 4 key. The animation plays correctly. Next, test equipment display. Remove test weapon socket display related nodes. Add the keypad 1 key event. Add spawn node. Class selected for equipment. Make transform. ID set to 3. SN set to 333. Amount set to 1. Call the add equipment function in player state. Run the game. Press the 1 key. The display is correctly. Add delay node. Set to 2 seconds. Remove the helmet from the equipment array in player state. Display the helmet object. Run the game. Press the 1 key. The display is correctly. Add keypad 2 key event. Copy and paste. Set the ID to 6 and the SN to 666. Run the game. Press 2. The display is correctly. Add keypad 3 key event. Copy and paste. Set the ID to 9 and SN to 999. Run the game. Press the 3 key. The display is correctly. Next, test the back weapon display. Add the keypad 4 key event. Add spawn node. Select class to weapon. ID set to 2, SN set to 222, amount set to 1. Set to the weapon 1 object in player state. Add the keypad 5 key event. Copy and paste. Set to the weapon 2 object in player state. ID set to 3, SN set to 333. Weapon position set to the right. Run the game. Press the 4 key. Press the 5 key again. Currently is displayed correctly without the equip backpack. Press 3 to equip the backpack. You can see that the weapons will automatically change position in the backpack after the backpack is equipped. When you remove the backpack, it will also change position automatically. Next, test the fashion display. Delete the node. Add the keypad 1 key event. Add spawn node. Select class for fashion. Make transform. ID is set to 3, SN is set to 333, and amount is set to 1. Call the add fashion function in player state. Add keypad 2 key event. Call the delete fashion function in player state. Run the game. Press the 1 key and the top is displayed correctly. Press the 2 key to delete the display. Add keypad 3 key event. Copy and paste. Set the ID to 5 and the SN to 555. Add the keypad 4 key event. Copy and paste. Run the game. Press 3 key. Pants display correctly. Press the 4 key to delete the display. Add keypad 5 key event. Copy and paste. Set the ID to 7 and the SN to 777. Add the keypad 6 key event. Copy and paste. Run the game. Press 5 key. Swim shirt display correctly. Press the 6 key to delete the display. Add keypad 7 key event. Copy and paste. Set the ID to 8 and the SN to 888. Add the keypad 8 key event. Copy and paste. Run the game. Press 7 key. Shoes display correctly. Press the 8 key to delete the display. Delete test node. Compile, save. Weapons, equipment, and an item. In the previous lesson, only objects that can be picked up have been created in my game mode. Once the objects are created, they are saved in my player controller. Listen in my player controller for the character entering or moving out of the item range. If an item is added to the character's pickup range, it is added to the item in range array in my player controller. And if an item is removed from the character's pickup range, it is removed from the item in range array. The firing line logic will be synchronized in my player controller. This logic will be performed in the tick event. To improve performance, the firing line correlation logic is performed only when there are pickable items within the character's range. Collision detection is performed by firing a ray at the character's facing direction, starting from the camera's center. The length of this ray determines the farthest distance the character can lock onto an item. We will set a distance value to lock onto the closest item the character is looking at. If the closest item is found within the range, the item is highlighted. At this point, if the user presses the Pick Up button, this highlighted item will be picked up. After an item is picked up, remove this item from the Items in Range array and the Pick Up Items array. After the item is picked up create the corresponding atom object and save it to my player state. The logic that needs to be executed for this atom. For example, picking up a weapon requires logic such as placing the weapon on the character's back, or making the character hold the weapon. The logic for picking up each atom is explained in more detail in later lessons. The character can throw atoms. Throwing an atom first removes the atom object from my player state. Then, the same logic for removing the atom is executed as for generating an atom object. Then, it generates a pickup object and saves the pickup object to my player controller. And it starts listening to this object to be in the character's pickup range. This is the whole process of picking up objects. The logic of picking up different objects will be explained in detail in later lessons. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create functions related to locking ground atoms. First, let's set the objects generated in my game mode to my player controller. Open my player controller. Add function named setPickUpAtoms. Category atoms overlap. Add an input variable named atoms. Type as an array of pickup base. Compile, save. Open my game mode. Open create atoms function. Add an output variable. Name it atoms. Type an array of pickup base. Return to the array when the loop is complete. Go to Event Graph. Get my player controller. Set the array. Compile, save. Next, listen for events where the character enters or moves out of atom range. Open my player controller. Add a function named executeBeginOverlap. Category atoms overlap. This is used to receive events when the character enters the atom range. Add an input variable named pickupObject. Type pickup-base. Add a function named executeEndOverlap. Category as atoms overlap. This is used to receive events where the character moves out of the atom range. Add an input variable named pickupObject. Type pickup-base. Open the setPickUpAtoms function. First, set the input array to the pickupAtoms variable. Loop the array. Call the boundPickUpObject into range event. Bound the execution event to the executeBeginOverlap function. Call the boundPickUpOverlap event. Bound the execution event to the execute begin overlap function. Compile. Open the execute end overlap function. Turn off the atom highlighting. Remove the out of range object from the atom in range array. Next, make the highlight items function. Add function named outline item. And category items overlap. Add an input parameter named item. Tab pick up base indicates the item object to be highlighted. Loop through the item in range array. Determine if it is the item object to be highlighted. If it is, make the item to enable highlighting. If not, then turn off highlighting. Compile, save. Before making the lock target item feature, add a display point in the screen center to see the effect better. Create a widget in the gameplay folder named main UI. The UI will be explained in detail later in the Making UI course, but it's just important to know that the widget is used to create the UI's blueprint. Open. Drag an image control to the canvas. Set the anchor point right in the center. Set the image size to 2:2. Check the box for size to content. Set the position to -1, -1. Set the color to red. Compile, save. This series of operations, you still do not need to understand very well what the specific meaning is. Later in the course, To Do UI will give you a detailed explanation. Here, it is only necessary to note that we have made a small red cube, so that it will always be displayed in the middle of the screen. Open my HUD. Add a Create Widget node. Select Min UI. Display this widget on the viewport. Compile, save, run the game. As you can see, the red dot you just made is displayed in the middle of the screen. Next, set the targeting item function. Return to the My Player controller. Add a function named targeting item. Category items pick up. This is used to lock the targeting item. Open event graph. Call the targeting item function. Add comment. Open the targeting atom function. First, to improve performance, determine if there is content in the range atom array before firing the ray. If there are atoms in the range, add a length trace by channel node. The purpose of this node is to emit a ray that collides with all visibilities objects. The starting point of the ray is set to the camera position. Open the viewport interface of my character. Select the camera component. You can see that the camera's position is the center point position of the screen. Return to the player controller. Next, calculate the end point of the array. First, get the positive direction of the camera. Multiply this direction by a length. Add the starting position. That is the end position of the ray. The range needs to be shown for testing purposes. Set the lifetime of drawing the debug line to full duration. Open SQL begin overlap function. Save the objects in the range to the atom in range array. Open pubg object. Remove UI components, and in the future we will not display the UI in this way. Run the game. Work around the object first. You can see that the ray is emptying in real time. When there is a red cube on the ground, it means that the ray has collided with another weapon, and this cube is the collision point. Press Shift F1 keys, then click Eject. You can see the point of collision between the ray and the ground more clearly. Click Process. Make the character move forward a bit to see the collision point is gone. This is because the length of the ray is not long enough to touch the ground. So, by controlling the length of the ray, you can control the ray of atoms that the character picks up. I think the range where characters can pick up atoms is a little further now. Set the range length to 450. Expand the collision information. Loop through the array of atoms that enter the range. First, unhighlight the atom. This action is equivalent to doing a reset. Then, start calculating the distance of all atoms from the collision point, and find the closest atom to the re-collision point. First, call the distance node to find the distance between the 2 points. Set the first point to the collision point, and set the second point to the location of the atom. Add a local variable named shortest distance. Type float indicates the shortest distance value. Compile. Set the default value to 10,000. Add a local variable named shortest atom of type pubg indicates the shortest distance to the atom object. Determine if the current atom distance is less than the shortest distance. If it is, save this distance value. And save this object. After all loops are completed, determine if the shortest distance object is found. Is found, then make this object highlighted. Run the game. You can see that the atom is highlighted according to the re-position. However, there is still a problem. For example, if we move the re farther away from the atom will still be highlighted. This can be solved by setting a maximum distance value. First, print the distance in real time. This will help us to determine how to match distance we should set as the maximum distance value. Run the game. We found that 75 is a more appropriate value for the distance. Delete the print distance value. Determine if the distance is less than 65. Then highlight the atom. Run the game. The atom will only be highlighted if the distance is less than 65. Set not to draw a debug ray. Finally, the atom needs to be saved for use when performing pickup operations. Add the variable named readyPickUpAtom. Tap Pickup Base. And category atoms indicates the atom that can be picked up. After setting the highlight, set the atom to this variable. If the shortest distance atom is not found, or the atom distance does not meet the requirements, set readyPickAtom to empty. Add comment. Add comment. Add comment. Hello everyone, I'm Big Cat. In the previous lesson, we explained the process of picking up atoms. The logic executed is different for each different type of atom. In this lesson, we will look at the specific logic of picking up weapons. First, there are two types of pickups. One is automatic pickup, which means that you press the F key to get the weapon. The other way is to pick up a weapon at a specific location. This means that the user will pick up a weapon and place it on the left side of the character's weapon bar, or on the right side of the character's weapon bar. First, let's look at the auto pickup logic. Auto pickup means the character walks up to the item and picks up the weapon by pressing F. First, determine if the character already has two weapons. If so, determine if the character is currently holding a weapon. If don't have a weapon in hand, replace the one on the left side of your back. If have a handheld weapon, replace it with the handheld weapon. If don't have two weapons, determine if don't have a weapon. If there are no weapon, place the weapon in the character's hand. If there is a weapon, place the weapon on the spare back. Let's look at the specified location pickup logic. Through the UI, directly choose to drag the weapon into position 1 or position 2. First, determine if there is a weapon at a specified location. If there is no weapon, place it directly on the back of the specified location. If there is a weapon, determine if the specified location is holding it. If not being held, the weapon in the specified back position is replaced. If in handheld, replace the handheld weapon. Determine the position where the weapon will be placed by picking it up in different ways. After determining the weapon position, execute the object-related logic. First, determine if the weapon is a replacement. If it is, create a new pickup weapon object based on the original weapon object state. This pickup object is then displayed into the level. The display position is the current character's position. Then, determine if there is a weapon accessory on the original weapon. If not, display the original weapon object. If yes, create the corresponding weapon accessory pickup object. Then, display to the level. The display position is the current character's position. Then, display the weapon accessory object. Then, display the original weapon object. Note that this part of the logic, in fact, is the logic for throwing weapons. This piece of logic is repeated later in the throws weapon clause. Create a new weapon object by picking up the object data. The object is then saved to my player state, determined by the preceding logic. The object is then displayed to the location specified by the character based on the previous logic. Finally, display the pickup object. This is all the logic that needs to be executed to complete the pickup of weapon. After the pickup logic is executed, an item change notification is sent. In a later lesson, we'll explain how to send a notification, mainly because the UI interface will listen for this notification and then change the interface's display. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we are going to make the first step in the weapon pickup, the logic associated with determining the pickup location. Open my HUD. Delete the display UI related node. Compile, save. Delete min UI file. Open my player controller. According to the previous lesson logic, we need to determine where to place the weapon after picking it up. Add function named AutoPosition. Category items pick up weapon. It is used to calculate the pick-up position automatically. Add a return parameter, named position, of type eWeapon position. Indicates the calculate position. Add a return parameter, named is on hand, type boolean. Indicates if it is on hand. First, check the number of weapons the character currently has. Add a local variable, named current amount, type integer. Indicates the current number of weapons. Add the sequence node. Determine from player state if there is a weapon on the left side of the back. If there is a weapon, add 1 to the number. Copy, paste. Also, determine if there is a weapon in your hand. Add comment. Determine if there are no weapons at all. If so, put the weapon in your hand, belonging to the left side of the bag. Add comment. Next, determine if there is an empty space less than 2 weapons. First, check to see if there are no empty space for handheld weapon. If it's not empty, determine the back position of the handheld weapon. If the weapon is currently on the left side of your bag, you return to your bag's right side and it is not in your hand. If the handheld weapon is on the right side of the bag, the return position is on the left side of the bag, and it is not in your hand. If the handheld weapon is empty, then the return position is the left side of the bag, and the hand is not empty. If the weapon on the bag's left side is not empty, the return position is the right side of the bag and is not in your hand. If the left hand side of the bag is empty, the return position is the left hand side of the bag and is not in hand. Add a comment. If the character already has 2 weapons, first, determine if the character has a handheld weapon. Replace handheld weapon first. If the character has a handheld weapon, determine where the handheld weapon is on the bag. If it is on the left, return to the left and it is in the hand. If it's on the right, the return position is on the right and is in your hand. If there is no handheld weapon, it replaces the weapon on the left side of the bag directly. Call this function to calculate the pick-up position when the character automatically picks up the weapon. Add comment. compile, save. Next, make the logic for specifying the pickup position. Add a function named assign position. Category items pickup weapon. Add input parameter named assign of type eWeapon position. Indicates the specified position. Add a return parameter named position of type eWeapon position. Indicates the calculate position. Add a return parameter named is on hand type boolean. Indicates if it is on hand. Compile. Determine if there is currently a handheld weapon. If there is a handheld weapon, compare whether the back position to which the handheld weapon belongs is the specified position. If it is, then return to the specified position and it is in hand. If there is no handheld weapon, then return to the specified position and it is not in your hand. If you do not have a handheld weapon, you return to the specified position and you do not have it in your hand. Compile, save. This completes the logic of calculation the pickup position. Hello everyone, I'm Big Cat. When picking up a weapon, if it is a replacement weapon, it performs the logic of throw the weapon. Whether throwing a weapon or other item, it will be displayed in the level after it is thrown. This process of displaying is the process of spawning an actor. In this lesson, we will create the logic to spawn an item in the level. Open my player controller. Add function named spawn pickup item and category items discard. This is used to spawn an item pickup object into the level. Add an input parameter named item base of type item base object reference. Here, creating an item pickup object must be based on an item object's data, so this item base represents the item object. Add a return parameter named pickup item type pickup base object reference. Indicates the created item object. Compile. Some of the variables in item base are reused later in the logic, and to improve the readability of the blueprint, these variables are promoted to local variables. At the top of function, get the item number via item base, promote it to a local variable, and name it ID. Get SN of the item via item base, promote it to a local variable named SN. When spawning an actor, you need to set the location. This location uses the character's current location. Get the character's current location via myCharacterRef. Make a transform. Promote to a local variable named transform. Next, start spawn item objects. The spawn logic for each item is somewhat similar to the logic previously used to generate items in game mode. Open my game mode. Open the generate items function. Copy the spawn actor partial node. Go back to my player controller and paste. Delete all array operation first. Then delete all variable settings. Then switch item tab. Set transform ID as N. Weapons have default magazines which may have bullets in them. Convert the item base class to a weapon object type. Get the number of bullets and set it. The number of bullets is not fixed. You need to get the amount from the item base and set it. Health can be stacked and the amount need to be set. Bullets can be stacked and the amount needs to be set. Create a new local variable named created_item. Tap pickup base. Adjust the node location. Add comment. After creating the object needs to be added to the pickup item array to start being picked up by the character. Add a sequence node. Save the object to the createItem variable after spawn is complete. Add the newly created object to the pickup_item array. Bound the begin overlap event. Bound the end overlap event. Then we'll do one particularly important piece of logic. First, set the box in the pickup object to not collision. Then set it to query only. First, the object is actually displayed to the level when spawn is done. This is when the begin overlap event is triggered, if the character is within range of the object box. But at this time, we have not yet bound the begin overlap event, so we will not to be able to listen for this begin overlap event. The current method allows the box to re-trigger the overlap event once. We can see the result when we test it later. Add comment. Finally, return the object. Note that I don't destroy the atom base in this function because other operations need to be done on the other after calling this function. So we can't destroy the object in this function. Compile, save. Next, test the spawn pickup atom function. Open event graph and add the keypad 7 key. Add a spawn actor node. Set the class to atom weapon. Make a transform node. Number of bullets is 50. Position is left. ID of bullets is 1. SN is 111. Amount is 1. Call the spawn pickup atom function. Set the input parameters. Run the game. Press the 7 key. An atom is generated into the level. Add the atom can be highlighted. Go back to the spawn pickup atom function. Discount to set collision. Run the game. Press the 7 key. The weapon object is also generated into the level, but can't highlight it. If you move out of object collision range and come back in, it is possible to highlight. This is what I just said. The begin overlap event was triggered once when the item was spawned, but the begin overlap event was not listened for at this point, so you need to re-trigger the begin overlap event after listening for it. Connect to set the collision node. Delete the test blueprint node. Compile, save. The function to spawn an object pickup is done, and all subsequent calls to this function can be made. Hello everyone, I'm Big Cat. In this lesson, we are making through weapon logic. Add function named discard weapon and category items discard is used to drop a weapon into the level. Add input parameter named atom weapon. Type atom weapon object reference. Indicates the corresponding weapon object. Compile. Determine if there are bullets in the weapon first. If there are bullets, throw all the bullets to the ground. Get the weapon's current bullets and determine if they are greater than 0. If it is greater than 0, add the spawn actor node. Select class as item ammo. Make transform. Get the weapon data from the weapon object, which will use the ammo ID setting to the ID. Call the generate SN function from my game instance. Set to SN. Get the current number of bullets from the weapon object. Set to the number. Call the generate pickup item function. This object of spawn is used to call the generate pickup item function. Set the number of bullets in the weapon to 0. Add a comment. Call the spawn pickup item function. Create the weapon pickup object into the level. Then, check the weapon object for weapon accessories. Add sequence node. Check to see if there is a set. If there is a set, create a set pickup object. Distribute the object. Check if there is a forget. Copy. Paste. Get the forget object. Check if there are magazines. Copy. Paste. Get the magazine object. Check for muzzle. Copy. Paste. Get the muzzle object. Check for gun bastock. Copy. Paste. Get the bastock object. Add comment. Determine if the weapon is on hand. If yes, set the weapon in hand to empty. If not, determine the location of the weapon. Set the corresponding weapon to empty. Add comment. Display the weapon object. The throw weapon function is done. You can call this function anytime you need to use the throw weapon function later. Compile, save. When the user presses the G key, the weapon throwing action is triggered. Enter event graph. Respond to the discard weapon input event. Determine if the user is not prone. Throwing weapons is not allowed while prone. If the user is not prone, my character will determine if the Montagi is currently playing. Determine that no Montagi is playing. If a montage is playing, the character is performing an action and is not allowed to throw a weapon. If the montage is not playing, determine if the handheld weapon is valid. If the montage is valid, throw the handheld weapon. Call the throw weapon function. If there is no handheld weapon, determine if the weapon on the back's left side is valid. If the weapon is valid, call the discard weapon function. If there is no weapon on the back's left side, determine if the weapon on the right side of the back is valid. If the weapon is valid, call the discard weapon function. Add comment. Compile, save. Next, test the weapon discard function. Add a keypad 1 event. Open my character. Delete test node. Compile, save. Add spawn actor node. Class set to atom weapon. Make transform. set on hand to true, ID to 1, SN is 111, number is 1. Set to handhold weapon. Copy and paste. Position is set to right. On hand set to false. ID is 3. SN is 333. Run the game. Press the 1 key. Press the G key. No action is performed. Look to see where a problem has occurred. Find the through weapon event. Here, you need to determine that the montage animation is not currently playing. Run the game. Press the 1 key. Press the G key. Throw the weapon in hand. Press the G key again. The back weapon is thrown. Delete Hello everyone, I'm Big Cat. This lesson deals with logic related to making objects that pick up weapons. Open my player controller, add function, and name it Pick Up Weapon. This will be used to execute the pick up weapon logic. Add an input parameter and pick up weapon of type pick up weapon object ref indicates the weapon object to be picked up. Add an input parameter named is assign, type boolean. Indicates if it is the assigned position. Add an input parameter named position of type E weapon position. Indicates the assigned position. Add sequence node. Call calculate assign position function. Promote the return position to a local variable named target position. Promotes whether the return is on hand to a local variable named target is on hand. Determine if the replacement is the assigned position. If it is not the assigned position, call function to calculate the position automatically. Copy and paste to save the return value. Add comment. Next, you need to determine if it is a replacement weapon. Add a local variable named replace weapon of type item weapon. Indicates the reference to the weapon object to be replayed. First, determine if you want to put it in your hand after picking up. If so, determine if there is a weapon currently in hand. If so, set to the replace weapon variable. If the target location is not handheld, determine if it is a replacement back weapon based on the location. If the assigned position is the left side of the back, and there is a weapon on the back's left side, it is a replacement weapon. If the assigned location is the right side of the back, copy and paste. Get the weapon to weapon object. Connect. Add comment. Next, process the related objects. First, determine if the replaced weapon object is valid. If the replaced weapon object is not empty, create a pickup object for this weapon and display it in the level. Call the discard weapon function. Then, create the new weapon object. Add the spawn actor node. Set the type to item weapon. Make a transform. Get the number of bullets from the pickup object and set it. Set the location. Set if it is in hand. Get the weapon ID from the pickup object and set it. Get the weapon SN from the pickup object and set it. Set the number of items to 1. Then, save the generated weapon object to player state. Determine if the weapon is in hand. If it is, set the generated weapon object to the hold gun variable in player state. If not, set the weapon to the weapon 1 and weapon 2 variables in player state, depending on their corresponding locations. Add comment. Add comment. Add comment. Next, you need to create a pickup entry function called after the user presses the pickup key. Add function named pickup item and category as items pickup. This is used to execute the pickup item logic. Add a return parameter named success of type boolean. Indicates if the item was successfully picked up. Determine if the ready pickup items is valid. If it is not valid, then the return pickup fails. If it is valid, switch the item type of the object. Different pickup logic is executed depending on the type of the pickup item. If it is a weapon type, call the pickup weapon function. Convert the object to the pickup weapon type and set. The logic performed by this function is automatic pickup logic, so it does not assign a location. When the pickup is complete, display the pickup object. Return pickup success. Compile, save. Next, add the interaction event. Open event graph. Add the interaction event. Call the pickup item function. compile, save. Next, test that the pickup weapon function is correct. Run the game. Pick up weapon. Since the character doesn't have a weapon, she will be holding it after pick up. Pick up another weapon and place it on the right side of the character's back. If you pick up another weapon, it will automatically display the handheld weapon, and the displayed weapon will be generated on the ground. We'll test the pick-up logic in more detail in later lessons after making the weapon switch. Picking up the weapon function is complete. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to make a weapon switch function. Switching between weapons will affect your character's state. First, let's make the change character state function. Open my player controller. Add a function named update character gun state. Category weapon changed. Get the handheld weapon object from player state. Determine if the handheld weapon is valid. If it is valid, set the character gun state to true. If not, set the character's gun state to false. Open the event graph. Find the weapon change event. Call the update character's weapon state function when the weapon changes. Run the game. Pick up the weapon. The character automatically switched to armed state. Before making the weapon switch function, make the play montage function. Open my character. Add the function named play montage. Category animation. Call this function whenever you need to play a montage animation. In this function, the animation will be played according to the current state of the character. Create an enumeration file in the data enu folder. Named eMontage tab. Indicates the type of montage animation to be played. Open. Add. The name is equip. Indicates the equipped weapon. New. Name is unequip. Indicates an unequipped weapon. New. The name is reload. Indicates a magazine change. New. The name is reload bullet. Indicates a bullet change. New. The name is fire. This means fire. New. The name is use. Indicates use of item. Save. Close. Go back to the play montage function. Add input parameter named montage tab. Tab eMontage tab. Save the montage tab as a variable named playing montage tab. And category as animation. Indicates the type of montage animation begin played. Set true to playing montage animation. The montage animation needs to determine the pose of the character when playing. Basically, every montage has a corresponding pose, such as standing, crouching, and prone. Determine if the montage is prone first. Switch the montage tab. Call the play montage animation node. Set the corresponding montage to prone. If it is a bullet reload, set the start magazine name to reload bullet. Add comment. If it is not prone, determine if it is crouching. Copy, paste. Set all montage animations to crouch. The montage change animation uses the standing animation. Add comment. If it's neither prone nor crouching, it's standing. Copy and paste. Set all montage animations to standing pose. Add comment. Compile, save. Play montage animation complete. Open the event graph of my player controller. Take back the weapon is triggered by a key, so you need to respond to the take back weapon press event. Respond to the weapon take back event. First, determine if the current character is holding a weapon. If she is holding a weapon, call the play montage function. Set the montage tab to unequip. Compile, save. When the unequip event is triggered, take back the weapon to the character's back. Bound the unequip event in event begin play. Assign the unequip event. The event is named event unequip. Add a function named takebackWeapon. Category weapon changed. Used to execute the takebackWeapon logic. Return to the event graph and call the function. Open the function. Set the gun in hand state to false. Set the weapons in hand property to false. Then, set the handhold weapon object to the back of the weapon's corresponding position. Get the handhold weapon and determine the back position it belongs to. If it is on the left, set it to weapon 1. If it is on the right, set the weapon to weapon 2. Then, set the handheld weapon to empty. Compile, save, run the game. Pick up a weapon, press the X key. The weapon is taken back to the bag. Open event graph. Respond to the keyboard keys 1 and 2. When the 1 key is pressed, equip the left weapon on the back. Save the left weapon as a variable named Ready Equip Weapon. Category as Weapon changed. When the 2 key is pressed, the right weapon is saved to the Ready Equip Weapon variable. Determines if the weapon to equip it is empty. If not, determine if the weapon is currently being held. If currently holding a weapon, you need to take back it first, so you need to play the take back animation first. If don't have a weapon, need to equip your weapon, so the equip weapon animation will play first. Add a comment. Friend the weapon take back event. After the weapon take back, determine if there is a weapon ready to equip. If there are, then the equip weapon animation will play. Add a comment. Assign the equip weapon event. Name it Event unEquip. Add a function named Equip Weapon. Category Weapon changed. Used to execute the Equip Weapon logic. Call this function. Add comment. Open. First, set the handheld weapon state to true. Set the weapon you want to equip to the handheld position. Set the weapon's handheld property to true. Determine where the equipped weapon belongs. If it belongs to the left, set the left side of the bag to empty. If on the right, set the right side of the bag to empty. Set ready to equip weapon to empty. Round game. Pick up a weapon. Pick up another weapon. Press 1. There is no enemy because the weapon currently being held belongs to the bag's left side. Press 2. Place the handheld weapon back on your back. Then equip another weapon on your back. Press X. Take back the weapon. Press 1. Arm the weapon. Press X. Take back weapon. Press 2. Equip weapon. The weapon switching function is complete. Different weapons will have different effects on movement speed. Open the Update Work Speed function. Get the handheld weapon. Determine if it is valid. Get the effect on the movement speed from the data of the weapon object. Use the current speed value, multiply by the impact value. Set to move speed. I'm Big Cat. In this lesson, we are going to look at the specific logic of picking up items. Items include weapon accessories, ammo, health, and burst, all of which can be placed in a backpack, so they have the same pick-up logic. There are two ways to pick up items. One is for the character to walk up to the item and pick it up by pressing the F key. The other is to drag the item directly into the backpack from the UI interface, and the logic is exactly the same in both cases. Once the item is picked up, it will be placed in the backpack, so you need to check if the backpack is enough. If the backpack capacity is executed after the item is picked up, the backpack capacity is not enough. If the backpack capacity is enough, then you start pressing the object. Determine first if the item picked up is ammo. If it is ammo, accumulate the ammo directly to the corresponding number of ammo in my player state. Then find out if there is a corresponding ammo object in the backpack. If there is an ammo object, then update the number of ammo in the object. After the update is done, you need to check if the number of bullets is 0, because the same logic applies if you are reducing the number of bullets. If the number of bullets is 0, this ammo object is deleted from the item object array. If there is no corresponding ammo object in the backpack, then create the ammo object. The object is then saved to the backpack object array. If there are no ammo bullets, then create the item object. Then save the object to the backpack item array. Finally, delete the pickup object. Then send notification of the item change. This is the complete logic for picking up an item. Next, we look at the logic for dropping an item. Dropping an item requires action on top of the UI. First, create the new pickup object. Then, spawn to the location of the character in the level. In the case of bullets, set the corresponding number of bullets to 0. Currently, discarding bullets will discard all of them. Delete the item object from the item array. Destroy the object. Finally, send a notification. This is the complete logic for discarding an item. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. Based on the pickup logic explained in the previous lesson, we will implement the pickup logic of weapon accessories, health, burst in this lesson. When picking up items, we need to determine if there is enough space in the backpack. If there is not enough space, we can't pick them up. First, let's make the backpack capacity check function. Open my player state. Add a function named check backpack capacity. Category is backpack. Used to check backpack capacity. Add input parameter named add weight. Type integer. Indicates the weight to be added. Add an output parameter named is enough. Type boolean. Indicates if the capacity is enough. First, calculate the total capacity of the current backpack. The backpack's total capacity is the different capacity plus the capacity of backpack the character is equipped with. Get the different backpack capacity from game instance. Promote to a local variable named total capacity. Loop the array of equipment. Determines if there are equipped backpacks. If there is a backpack, get the data in the equipment table via the backpack ID. Add the backpack capacity to the total capacity. Add comment. Then calculate the total weight of all items currently in the backpack. Add a local variable named items weight. Type integer. Indicates the current total weight of the items. Loop the array of items in the backpack. Add the weight of the items to the item weight variable. Add comment. Next, determine if there is enough space after adding the weight. Use the added weight plus the current total item weight. Determine if it is less than or equal to the total backpack capacity. If true, it returns enough. If false, it returns not enough. Add comment. Check that the backpack capacity function is complete. Compile and save. Next, make the pick up items feature. Open my player controller. Add a function named pick up goods. Category items pick up item. Add an input parameter named item tab pick up base. Add an output parameter named success of type boolean. Indicates if the pickup was successful. Call the check backpack capacity function in player state. If there is not enough capacity, print a message. When you do the UI cross later, will be displayed on top of the UI. Return failed. If backpack capacity is enough, switch item tab. Connect the weapon accessories and add spawn actor node. Set class to weapon accessories item. Make transform. Get the item ID by item. Get item SN. Amount is set to 1. Add the item to the item array. Copy. Paste. Connect the health. Set class to health. Get the amount and set. Copy. Paste. Connect the burst. Set class to burst. The pickup logic for all 3 items is more consistent. Just create the variable and put it in the backpack. Add the sequence node. Return successful pickup. Compile, save. Open the pickup item function. Call the pickup goods function. Connect weapon accessories, ammo, health, and burst to the pickup item function. Set pickup object. Determine if the pickup is successful. If successful, call to destroy the pickup object and return successful. If it fails, return failed. Compile and save. Open event graph. Add a response to the items changed event in event begin play. The event is named event items changed. Next, test to see if the item is picked up correctly. Since there is no UI at the moment, we check if the data is correct by printing. When items have changed, loop the items array. Print. Print the atom tab and atom ID. When the loop is complete, print the mark. Run the game. Pick up the atom. Print display correctly. We found that the tip backpack does not have enough capacity to pick up the atom. Printing atom contents will also be used later in the course. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, I'm going to create the pick up ammo function. Open the pick up goods function of my player controller. Ammo objects are not created here. They are automatically created in player state based on the number of bullets left, so you just need to update the number of bullets here. Open my player state. After the number of bullets has changed, you need to update the ammo object. Add the function named update ammo object. Category ammo. This function will update the ammo object according to the current number of bullets. Loop the atom object array. First, find the ammo object in the backpack. Determine if it is an ammo object. If it is, determine if the bullet number is 1. If it is 1, promote it to a local variable named ammo1. Indicates a 5.56mm bullet. If it is not 1, promote it to a local variable named ammo2. Indicates a 7.62mm bullet. Add a comment. When the loop is complete, determine if the number of 5.56mm ammo is greater than 0. If it is greater than 0, determine if the ammo1 object is valid. If valid, set the number of ammo1 bullets. If not, add a spawn actor node. Class select atom ammo. Make transform. ID to 1. Get the game instance. Convert it to my game instance. And call the generate SN function. Set amount. Add the created object to the atom array. If the current number of bullets is not greater than 0, then the current number of 5.56mm bullets is 0. Determine if the ammo1 object is valid. If it is valid, remove this object from the item array. Then, destroy this object. Next, determine the 7.62mm bullets. Determine the same way as for 5.56mm bullets. Copy and paste. Get the number of bullets modified to 7.62mm. The object is modified to ammo2. ID modified to 2. Add comment. Add comment. Compile and save. Open the setAmmo556 function and call the updateAmmoObject function when the number is changed. Open the setAmmo762 function and call the updateAmmoObject function when the number is changed. Compile and save. Next, make the updateAmmoObject function. Add the function, name it updateAmmoAmount. And category is ammo. Add input parameter, named ID, type name, indicates the ID of bullets to be updated. Add input parameter, named add, type boolean, indicates if the number of bullets is to be added. Add input parameter, named amount, type integer, indicates the number of bullets to update. If it is 0, then the current bullets will be 0 out directly. First, determine if the amount of bullets to update is 0. If 0, to determine if the number of bullets is equal to 1. If it is equal to 1, call the set556ammo function. Set the value to 0. If it is not equal to 1, call the set762ammo function and set the value to 0. Add comment. If the number is not 0, determine if the number is added. Copy and paste. if the amount is an add amount. Add the amount to be added with the current 556 bullets count. Set the value. Same as 556 bullets, get 762 bullet count plus the count to be added. Set the value. Copy and paste. If the number is reduced, subtract the amount to be reduced by the current 556 bullet count. Set the value. Get the number of 762 bullets minus the number to be reduced. Set the value. Compile, save. Back to my player controller's pick up goods function. If picking up ammo, call the update ammo amount function in player state. Set the ID. Select as add. Set the number. Compile, save. Logic complete. Test next. Find the place to print the content of the array. Add a width. To make it easier to view the bullet stacks, open my game instance and set the different backpack capacity to 100. Run the game. Pick up the 556 ammo. Pick up another 556 ammo. Pick up another 762 ammo. You can see the bullets stacking. Change the different backpack capacity setting to 50. Compile, save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to make discard items. This includes weapon accessories, health, burst, and ammo. Discard items must be operated from the UI. In this lesson, we'll complete the functionality logic of the discard item first. Open my player controller. Add a function named discard item. Category items discard. Add an input parameter named item with type item base object reference. Indicates the item object to be discarded. Call the spawn pickup item function. Determine if the item to be discarded is an ammo. If it is an ammo, you need to set the corresponding number of bullets to 0. Call the update ammo amount function in my player state. Set the ammo ID. Set the number to 0. Delete the item object from the item array. Determine if the discarded item is valid. is valid, destroy the object. Compile, save. Next, test the discard item. Add keypad 1 key event response. Get the array of items. Determine its length is greater than 0. If it is less than 0, there is no current item. Get the first item in the item array. If it is greater than 0, call the discard item function. Run the game. Pick up some items first. Press the 1 key. The first item in the current array is deleted, and a pickup object is generated into the level. Press the 1 key again. Same result. Delete the test node. Hello everyone, I'm Big Cat. In this lesson, we are going to look at the logic of picking up equipment. Here, equipment includes helmet, vest, and backpack. These 3 types of equipment have a very similar pick-up logic. There are 2 ways to pick up the equipment. One is for the character to walk up to the equipment and pick it up by pressing F. The other is to pick it up directly from the UI. And the logic is the same in both ways. The first, check is whether the item being picked up is a backpack. If it's a backpack, then you need to check the backpack capacity. For example, the current character backpack has 150 capacity, plus the character has 50 capacity by default, for a total of 200 capacity. The items in the backpack take up a total of 180 capacity. If the backpack is replaced, the backpack's total capacity will be less than the capacity needed for all the items in the current backpack. Replacing a backpack in this case is not allowed. If the capacity is not enough, the backpack is not allowed to be displayed. If the capacity is enough or not a backpack, check if it is replacement equipment. If it is replacement equipment, create a new pickup object based on the current equipment data. Then spawn this object into the level. Once created, or if it's not replacement equipment, the corresponding item object is created, displayed to the specified location on the character. Delete the old equipment object from the equipment array in my player state. Then save the new equipment object to the equipment array. Finally, send the equipment change notification. This is the complete process of picking up a piece of equipment. Next, we look at the logic of discarding equipment. There is only one way to discard, dragging it from the equipment bar to the ground. First, check if the one to be discarded is a backpack. If it's a backpack, check if the capacity is enough after discarding the backpack. If it does not have enough capacity, it determines that the backpack cannot be discarded. If there is enough capacity, or the discarded backpack is not a backpack, create the corresponding pickup object. Then spawn to the location of the character in the level. Remove the equipment object from the equipment array. Destroy the object. Finally, send a notification. This is the complete logic. Hello everyone, I'm Big Cat. When picking up equipment, you need to discard the current equipment if it is a replacement. In this lesson, we are going to create the discard equipment function. In the previous lesson, we talked about how if you are replacing a backpack, you need to check if the new backpack has enough capacity. Likewise, if you are dropping a backpack, you need to check if the backpack has enough capacity after you drop it. If there is not enough capacity, the backpack is not allowed to be discarded. You need to make a function to check if there is enough capacity in the backpack. Open my player state. Add a function named check replace backpack. Category backpack. Add input parameter named atom. Tap atom base indicates the backpack object to be picked up. If the backpack is discarded, this object is empty. Add an output parameter named isEnough. Tap boolean indicates if the new backpack capacity is enough. Add a local variable named atom's weight. Tap integer indicates the total weight of all current atoms. Get an array of all atoms. Loop array. Get the atom weight. Plus the atom's total weight. And then set to the total weight of the atoms. Add comment. After the loop is complete, determine if the picked up atom is valid. If valid, get the capacity of the new backpack in the data table by ID. Save as a local variable named pickup_capacity. If not valid, set pickup_capacity to 0. Use the new backpack capacity plus the different capacity. Determine if it is greater than or equal to the total weight of all atoms currently in the backpack. Return the result. Add comment. Compile, save. Next, make the discard equipment function. Open my player controller. Add a function named discard equipment. And category atoms discard. Add the input parameter named atom. Tap atom base. Indicate the atom object to be discarded. Add a return parameter named success. Of tap boolean indicates if the discarded was successful. Determine if the atom to be picked up is a backpack. If it is a backpack, call the check display backpack function. If the capacity is not enough, print a message. Add comment. Call the spawn pickup atom function to create a pickup object into the level. Then, delete the object from the equipment array. Finally, destroy the object. Add a comment. Returns discard success. Hello everyone, I'm Big Cat. In this lesson, we are going to create pickup logic. Open my player controller. Add a function named pickup_equipment. Tap atoms pickup_equipment. Add an input parameter named atom. Tap pickup_base. Indicates the object reference of the atom to be picked up. Add an output parameter named success. Tap boolean. If or not the pickup was successful. Determine if the atom to be picked up is a backpack. If it is a backpack, call the check display backpack function. If the capacity is not enough, print the marker. Add a comment. Next, check if it is replacement equipment. Loop through the array of all equipment. Determine if the type of the atom in the array is equal to the type of atom picked up. If yes, save the atom object to a local variable named currentAtom. Determine if currentAtom is valid after the loop completes. If it is valid, call the discard equipment function. Note here that the discard equipment function checks if the item can be discarded or not. In this case, it's replacing the backpack, not just discarding it, and the logic above has already checked if the backpack can be displayed, so there's not need for a capacity check here. Modify the discard equipment function. Open. Add input parameter named isCheck, type boolean, used to indicate whether or not to check the backpack's capacity. Before checking the backpack capacity, make a determine. If its check is true, then the backpack capacity check is performed. Go back to picking up the equipment function. Add comment. Then, create the equipment object by picking up the item information. Add the spawn actor node. Class select item equipment. Make transform. Get the ID by item. Get SN by item. Get amount by item. Add the object to the equipment array. Add comment. Compile, save. Call this function next. Open the pickup function. Call the pickup equipment function when the type of the pickup item is a helmet or a vest or a backpack. Determine if the pickup was successful. If not, return false. If the pickup is successful, the connection destroys the object. Compile, save. Open the pickup equipment function. Return successful when all execution is complete. Run the game. Pick up the equipment. Display correct. Pick up a level 2 backpack. Pick up items until the level 2 backpack is full. Pick up the level 1 backpack again. This indicates that there is not enough space to pick up. Hello everyone, I'm Big Cat. In this lesson, we will look at the logic of picking up fashion. There are two ways of picking up fashion. One is for the character to look up the fashion and pick it up by pressing the F key. The other is to drag the fashion directly from the UI into the fashion bar. And the logic is the same in both cases. The first, check is whether fashion is a replacement. If it is a replacement fashion, then a new pickup object is created based on the current fashion data, and this object is spawned into the level. Note here that when picking up a bodysuit, both the top and the pant will be displayed if the character is wearing both a top and pant. So here, it is possible to have both garments displayed at the same time. When the creation is complete or not a replacement garment, create the corresponding atom object. This is displayed at the location specified by the character. Delete the old fashion object from the fashion array in my player state. Then save the new fashion object to the fashion array. Finally, send a fashion change notification. This is the complete process of picking up a fashion. Next, we look at the logic for discarding fashions. Discarding fashions is done on the UI. There is only one way to discard a fashion, by dragging it from the fashion bar to the ground. Create the corresponding pickup object and then spawn to the location of the character in the level. Delete the fashion object from the fashion array. Destroy the object. Finally, send a notification. This is the complete logic for discarding fashions. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to create a pick up fashion and a discard fashion function. Let's start with the discard fashions function. Open my player controller. Add a function named discard fashion with the category items discard. Add an input parameter named atom. Tap atom base. Call the spawn pickup atom node. Create pickup objects into the level. Delete in the fashion array. Destroy the object. Compile, save. Add function named pickup fashion. Category items pickup fashion. Add input parameters named atom. Tap pickup base. The first step is to find the fashion atom being displayed. Loop the array of all fashion items. There are 3 cases where displacement is required. Converting an object type to fashion. In the first case, the fashion are of the same type. In the second case, the bodysuit is currently being worn. And the pickup is a top or pant. In the third case, a shirt or pant is currently being worn, and the pickup is a bodysuit. Determine if any of these three possibilities are present. Add a local variable named replaced items. Type item base array, used to store the replaced fashion object. If so, add the item to the replaced items array. Add a comment. Add comment. Add comment. Add comment. When the search for the replaced item is complete, loop through the array of replaced items. Call the discard fashion function. Add comment. Finally, create the fashion object by picking up the item information. Add the spawn actor node. Class select item fashion. Make transform. Get the ID by item. Get SN by item. Get amount by item. Add the object to the fashion array. Add comment. Compile, save. Next, call the pickup fashion function. Open the pickup item function. Call the pickup fashion function when the type is fashion. Set the pickup object. When the pickup is complete, display the object. Compile, save. Run the game. Pick up the swimsuit. Display correctly. Pick up the shirt. Put on the shirt and discard the swimsuit. Pick up the pants. Pick up the swimsuit. The swimsuit is put on, and the shirt and the pants are discarded. Try the same type of fashion replacement. Pick up the pant. Pick up the pant again. The pant is replaced correctly. Pick up and discard fashion functions are completed. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we will look at the logic of equivalence. Hello everyone, I'm Big Cat. In this lesson, we will look at the logic of equipping and removing weapon accessories. Let's start by looking at equipping weapon accessories. Equipping a weapon accessory means dragging it from the ground or backpack onto the weapon. This operation needs to be done on the UI. First, check if the weapon accessory is a replacement. If it is a replacement, you need to check that the backpack capacity is enough, as the replaced weapon accessory will automatically be placed in the backpack. If the backpack capacity is not enough, a low backpack capacity message is displayed. If the backpack capacity is enough, the replaced weapon accessory is placed in the item array. Then, check whether the weapon accessory to be equipped is on the ground or in the backpack. If it is in the backpack, the weapon accessory to be equipped is deleted from the item array. If on the ground, first create the corresponding item object and then display the pickup object. The weapon accessory object is then saved to the weapon object to which it belongs, and the display is updated. Finally, send a notification of changes to the weapon accessory. This is the complete process for equipping a weapon accessory. Next, we look at the logic of removing a weapon accessory. Removing a weapon accessory can be done either by placing the weapon accessory in a backpack or throwing it on the ground. First, determine whether it is to be placed in the backpack or thrown on the ground. If it is in the backpack, check that the backpack has enough capacity. If there is not enough capacity, a low backpack capacity message is displayed. If the backpack capacity is enough, remove the weapon accessory from the weapon to which it belongs. Then, save the item accessory object to the item array and update the weapon's display. If it is thrown to the ground, first create the corresponding pickup object and then display it to the character's position in the level. Remove the weapon accessory from the weapon it belongs to. Then, display the weapon accessory object. Finally, send a notification of the change to the weapon accessory. This is the complete process for moving a weapon accessory. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to be equipping the weapon accessory function. Whether you are equipping or unequipping a weapon accessory, you need to update the data and the display. First, we will create a function to update the data and display of the weapon accessory. Open player state. Add a function named updateWeaponACC. Category WeaponACC. Add an input parameter named position of type E weapon position, used to indicate the position of the weapon to which the accessory to be updated belongs. Add an input parameter named ACC type of type E weapon ACC type, indicates the type of weapon accessory. Add an input parameter named item weapon ACC. Type item weapon ACC indicates the weapon accessory object to be updated. If this object is empty, it means that the weapon accessory is removed. First, determine the position of the weapon to which the accessory belongs. If it is left, determine whether the weapon1 object is valid. If it is valid, promote the weapon1 object to a local variable named weapon. If not, it proves that the weapon on the back's left side is belong hand, and set the hand weapon object to weapon. Copy and paste. If the weapon is the right hand side of the back, set the weapon2 object to weapon. Add a comment. Then switch the weapon accessory tab. If the weapon is a set, call the update set function in the weapon object. If it's a muzzle, call the update muzzle function. If it's a frigate, call the update frigate function. If it's a magazine, call the update magazine function. If this is a backstock, call the update backstock function. Add comment. Sending an event after the update is complete. Add an event named event weapon ACC changed. Add an input parameter named is remove. Tab boolean indicates whether the accessory is removed or not. Add an input parameter named weapon of tab atom weapon. Add an input parameter named ACC pubg. Tab atom weapon ACC. Add an input parameter named ACC tab. Tab e-weapon ACC tab. Call event. Determine whether the weapon accessory object is valid, set to whether the accessory is removed. Set the weapon object. Set the weapon accessory object. Set the type of accessory. Add comment. Compile, save. Update the weapon accessory object and show the function as complete. This function can be called both for equipping and removing the weapon accessory. Open my player controller. Add a function named equip accessory. Category items pick up weapon. Add an input parameter named item base of tab item base. Indicates the weapon accessory object to be equipped with maybe a pickup object or an item object. Add an input parameter named is from around. Tab boolean indicates whether the item is coming from the ground. Add an input parameter named weapon of tab item weapon. Indicates the weapon object that the accessory is to be equipped to. Add an output parameter named success of tab boolean. Indicates whether the equipping was successful. Determine first if the accessory is equipped from the ground. If so, convert the item to a pickup object. Get the accessory tab. Promote the accessory tab to a local variable named ACC tab. If not, convert the item an item object. Get the accessory tab. Set the accessory tab to the ACC tab variable. Add comment. Next, check if the accessory can be equipped on the weapon. Get the accessory data. Explain it. And keep the weapon ID array. Promote the array as a local variable and name it weapon ID is. If it is an item object, get accessory data. Append it. And keep the weapon ID as array. Set the array to weapon ID as. Get the weapon ID array. Call the friend node. Get the weapon object. Get the ID. Set. If equal to -1, the corresponding weapon ID was not found, and the length of the weapon ID array is greater than 0. If the ID array is 0, all weapons are available. Determine. Return failed. Add comment. Switch accessory tab. In the case of a set, get the set object from the weapon object. Promote to local variable named replaced ACC obj. If it is a model, get the model object. Set. If it is a free grid, get the free grid object. Set. If it's a magazine, get the magazine object. Set. If it's a bastock, get the bastock object. set. Add a comment. Next, check if the backpack capacity is enough. First, determine whether the weapon accessory being displayed is valid. If it is valid, call the check backpack capacity function in player state. Get the weight of the weapon accessory being displayed. Subtract. Get the weight of the weapon accessory to be equipped. Set to add weight. Determines if the capacity is enough. If not, the backpack does not have enough space for the weapon accessory replacement. Return failed. If the capacity is enough, call the add item function in player state. Set the item to the weapon accessory to be replaced. Add comment. Determine again whether the weapon accessory is coming from the ground. If so, create a new weapon accessory object. Make transform. Get the ID from the item base object. Get SN. Get amount. Promote the created object as a local variable named weapon ACC-OBG. Tab item base. Display the item base object. If it is not coming from the ground, prove that it is coming from the backpack. Call the remove item function in player state to remove it from the backpack. Set to the weapon ACC object variable. Add comment. Add comment. Finally, update the weapon accessory object data and display. Call the update weapon accessory function in player state. Get the weapon location from the weapon object. Convert the weapon ACC OBJ object to a weapon accessory object. And get the accessory tab. Setting up the weapon accessory object. Add comment. Equip a weapon accessory function logic complete. Compile. Save. Next, test equip the weapon accessory. Open the event graph. First, test equipping the weapon accessory from the ground. Respond to the keyboard key 1. Create a weapon accessory pickup object. Make transform. The ID is 1, SN is 111, amount is 1. Call the equipment accessory function. Set the accessory object, set to true whether from the ground. Weapons set to handheld weapons. Run the game. Pick up a weapon. Then press the 1 key. The accessory is displayed correctly. Next, test the replacement weapon accessory. Respond to the keyboard key 2. Copy and paste. Set the ID to 2. SN is 222. Set amount to 1. Respond to keypad 3. Loop the array of items. Print. Print the item tab, item ID, and weight. When the loop is complete, print the marker. Run the game. Pick up a weapon. Then press the 1 key. Press the 2 key again. The scenes are replaced. Press the 3 key again. The wristplate sight is placed in the backpack. Next, test equips the weapon accessory from the backpack. Respond to keyboard key 4. Call the equip weapon accessory function. Get the first item from the item array and set it to item base. Get the handheld weapon and set it up. Run the game. Pick up the weapon. Then press the 1 key. Press the 2 key. The sight are displayed. Press the 3 key. The replaced sight is placed in the backpack. Press 4. The sight in the backpack replaces the current sight. Press 3. The data and display are correctly. A final test when the backpack is low on capacity. Round game. Pick up the weapon. Press the 1 key. Press the 2 key. Pick up an amount. Pick up another item. Press 3. The total weight of all items is now 50, which is exactly the backpack's maximum capacity. Press the 4 key at this point. You can see that the replacement has failed, and that there is not enough capacity for replacement parts. After the end of the run, an arrow is displayed. Open the Equipment Accessory function. Here, the capacity should be calculated using the replaced accessory object minus the item base. Round game. Pick up the weapon. Press the 1 key. Press the 2 key again. Pick up the item. Press the 3 key. Press the 4 key. The low capacity was correctly displayed. No error when the run is finished. Here, you need to determine whether the accessory to be equipped with are coming from the ground. If it is not coming from the ground, use the phase reduction value. Hello everyone, I'm Big Cat. In this lesson, we are going to create a function to remove weapon accessories. Open my player controller, add a function named removeAccessory. Category items discard. Add an input parameter. Named item ACC. Tap item base. Indicates the weapon accessory to be removed. Add an input parameter. Named is to around. Of tap boolean. Indicates whether the accessory is to be thrown to the ground. Add an input parameter. Named weapon. Tap weapon object. Indicates the weapon object where the weapon accessory is to be removed. Add an output parameter, named success. Tap boolean indicates whether it was successful removed. Determine if it is to be thrown to the ground. If so, call the spawn pick up item function. Create a pickup object. Call the update weapon accessory function in player state. Get the weapon location from the weapon. Convert item ACC to a weapon accessory item tab. Get the weapon accessory tab. Display the weapon accessory object. Add comment. If it is not discarded to the ground, the weapon accessory is placed in the backpack. Call the check backpack capacity function in player state. Get the weight from item ACC. Determine if the capacity is enough. If it is not enough, print the message. returns failed. If the capacity is enough, call the update weapon accessory function in player state. Get the weapon location from the weapon. Convert item ACC to a weapon accessory item tab. Get the weapon accessory tab. Call the add item function in player state. Add the weapon accessory to the item array. Return success. Add comment. Remove the weapon accessory logic is completed. Compile, save. Next, test for removing the item accessory. Open the event graph. Respond to the 5 keys of the keyboard. Call the remove accessory function. Get the handheld weapon object. Get the sight accessory object from the weapon object. And set it to item ACC. Set up the weapon object. Run the game. Pick up a weapon. Then press the 1 key. Press the 5 key. Remove the sight. Press the 3 key. The removed sight is placed in the backpack. Set is to around to true. Run the game. Pick up a weapon. Then press the 1 key. Press the 5 key. The sight is thrown to the ground. Remove the weapon accessory function is completed. Delay the blueprint node for testing. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. Starting with this lesson, we will be making weapon-related functions. This lesson will start with making the aiming function. There are 2 ways to aim. One is to hold down the right button and aim, and the other is to open the sight. We will start by making the aiming function by holding down the right mouse button. When the right mouse button is pressed, the camera will have an animation that moves the camera forward. Let's start by creating this animation. Open my character's event graph. Add a custom event. Named hold aiming. Use this to play the aiming animation. Add an input parameter named forward of type boolean. Indicates whether or not the aiming animation is playing in forward direction. Determine if it is playing in forward direction. Add a timeline node named TL hold aiming. Add a track of type float. Name it %. Add a key point. Set time to 0 and value to 0. Add key point. Set the time to 0.3 and the value to 1. Set the length to 0.3. This % value is 0 when the time is 0 seconds, and 1 when the time is 0.3 seconds. Select a key point, right-click, and select User. Adjust the curve. This will have a slowing effect. Go back to the event graph. If playing in the forward direction, connect play. If it is playing in reverse, connect reverse. Set the relative position of the camera at each update. Add the lerp node, type vector. Point A indicates the different position of the camera. Point B indicates the camera target position. Next, see what the target position of the camera should be. Open the viewport interface. Move forward to increase the value of the camera's x-axis. It also moves downwards. Moving downwards decreases the value of the camera's z-axis. The camera will also move to the right. Move right to increase the value of the camera's y-axis. Go back to the event graph. Set the camera's target position to 105 minus 30. After the hold aiming event has been called, the camera will play an animation. Compile. Save. Next, respond to the targeting input event. Open the event graph of my player controller. Friend the aiming input event. First, disconnect the node as done in the previous class. When pressed, first determine whether the weapon is currently held or not. Add a variable named hold aiming of type boolean. Category weapon aiming indicates whether the weapon is currently being aimed with the hold down method. Set hold aiming to true. Set the aiming state to true. Call the hold aiming function from my character. Set positive play to true. Execute the calculate handhold weapon socket function and update weapon display function. Run the game. Pick up a weapon. Press the right button. Play the animation correctly. When the mouse is released, first determine if you are currently performing a press to aim. If so, set the hold aiming to false. Set the aiming state to false. Call the hold aiming function in my character. Set forward play to false. Execute the calculate handhold weapon socket function and update weapon display function. Run the game. Press the right mouse button to play the aiming animation. Release the right mouse button to play the reward animation. In some cases, aiming is not possible or may be cancelled. Add a custom event named reverse hold aiming, which performs the same as the mouse left. Friend the Alt key position in response to a press. Call the reverse hold aiming function when the Alt key is pressed to unaim the hold aiming. Run the game. Pick up the weapon, hold down the right mouse button, press the Alt key to unaim automatically. Friend the position of the jump button in response to a jump. After pressing the jump button, first, judge that you are not currently aiming. You cannot jump if you are aiming. Friend the discarded weapon if the discarded weapon is a handheld weapon. Hello everyone, I'm Big Cat. Starting with this lesson, make the function to turn on the sight to aim. Use a separate arm, another camera from this function. In this lesson, we will add the arm first. Open the viewport window of my character. Add a camera component named FPS camera. Use this camera with the viewport turned on. Place the camera on the character's hand and set the Z value of location to 75. Check the use control rotation value. This will allow the arm to rotate as the camera rotates. Add a skeletal model component to the camera named FPS arm. This is used to display the character's independent arm. Set the model SKM FPS arms. Rotate the arm so that it is oriented correctly. Set the Z value of rotation to -90. Set the Z-axis position to -159.52. The default setting is hidden. The arm is only displayed when the sight is switched on. Compile, save. An arm model has been added, so we need to create an animation of the arm. Create an animated blueprint in the blueprint character folder. Select the arm skeletal model and name it FPS arm blueprint. Open the event graph. Determine if it is valid. Convert to my character. If valid, promote to variable named my character ref. Get the character speed vector. Get the speed value. Promote the speed value to a variable named speed. Get whether currently aiming by character. Promote to a variable named is aiming. Open the animation graph. Add a state machine named locomotion. Connect the state machine to the default slot. This slot is used for blending montage animations. Connect the output pulse. Open the state machine. Drag in the idle animation. Connect the entry. Drag in the aiming idle animation. Connect idle to aiming idle. Enter. Return the isAiming variable. Connect aiming idle to idle. Enter. Returns the not isAiming variable. Drag in the aiming work animation. Connect aiming idle to aiming work. Enter. Returns a speed value greater than 0. Connect aiming work to aiming idle. Enter. The return speed value is equal to 0. ARM animations are only possible when aiming, so it is enough to have these animations. Compile. Save. Return to my character. Set aim animations. Compile. Save. Next, create an ARM shooting montage. Friend the ARM shooting animation. Right-click and create an animation montage. Open. Add the event, name it End, Fire. Drag it to the last frame of the animation. Save. Close. Move the file to the Blueprint Character Montage folder. Open the event graph for FPS Aim Blueprint. Respond to the Fire End event. Add an event dispatch named Event on Fire End. Trigger this event. Compile and save. Next, add a weapon socket in the ARM. Open the ARM skeletal model. Set the preview animation to Aim Idle. In the right-hand skeletal, there is a socket named Weapon Socket. The resource for the preview is the weapon. Adjust the socket position and rotation values. I have adjusted the position of the socket in advance. To test the look effect, you need to switch to Aiming Idle. In this lesson, we will first write some blueprints for testing. Open my character's event graph. Add an event that responds to 3 key keyboard input. Set to show the first-person aim. Hide the my character model. Turn off the third-person camera. Activate the first-person camera. Add a variable named isSight_Aiming. Type Boolean, category character state. Indicates whether the sight aiming is currently on or not. Set whether isSight aiming is on or not to true. Open the Update Weapon Display function. Before updating the handheld weapon display, you need to determine that you are not currently aiming with the sight on. This update cannot be performed with sight on, as we need to place the weapon on top of the first-person arm. Go back to the event graph. Get the handheld weapon and set up the transform. Get the transform for the ARM socket. The name of the socket is Weapon Socket, which was created in the previous lesson. Add the Attach to Component node. Target is set to handheld weapon. Parent is set to first-person aim. The name of the socket is set to weapon socket. Set the rule for location to snap to target. The rule for rotation rule is set to keep word. The weapon is attached to the character model after pick up, and since we have hidden the character model and all child objects, we need to show the weapon object. Get the handheld weapon object. Set the display state of the skeletal mesh in the weapon object. Set it to be displayed and affect all sub-objects. Respond to the file key. Set the aiming state to true. Run the game. Pick up a weapon. Press the 3 key. Press the 5 key. You can switch to the first-person aiming state. Hello everyone, I'm Big Cat. In the last lesson, we added the first-person arm. In this lesson, we are going to adjust the arm's position. The position of the weapon on the arm is fixed. However, each weapon's head is different, and the head of the sides is also different, so we need to adjust each weapon's position on the arm. Create a date table and store the position of the arm of each weapon in the date table. Create a structure in the Data's table structure folder and name it STArms location. Open. Set the variable named location, tab vector. Only this one variable is needed. Save. Close. Create a date table in the date table folder. Select STArms location and name it DTArms location. Open. Whenever we adjust a location, it is recorded in this date table. Run the game. Pick up an AK weapon. Press the 3 key. Press the 5 key. First, adjust the position of the arm when using an AK weapon. In order not to waste time, I have adjusted the appropriate position values in advance. Open my character. Set the arm positions to -11, 0.36, -165.5. Run the game. The position is correct. Record this value in the date table. Add a row of data. Set the name to 20. 2 indicates the weapon ID. 0 indicates the site ID, or 0 if there is no site. Vector is set to -11, 0.36, -165.5. Save. Next, adjust the position of the arm when using the M4 weapon. Set the arm position to -8, 0.36, -168.85. Run the game. Position is correctly. Add a row of date. Name set to 10. Vector set to -8, 0.36, -168.85. Save. Next, adjust the position of the arm when using the AWM weapon. Set the arm position to -8, 0.36, -164.45. Run the game. Position is correctly. Add a row of data. Name set to 30. Vector set to -8, 0.36, -164.45. Save. Next, Adjust the position of the arm when the M4 weapon is equipped with a doubled sight. Open my character. For ease of testing, equip a sight directly on the weapon. Add the spawn actor node. Make transform. Set class to atom weapon ACC. ID set to 1. SN set to 111. Number set to 1. Get control. Convert to my player controller. Call the equip weapon accessory function. Set atom base. Get the handheld weapon from player state. Set arm position to -13, 0.36, -170.85. Run the game. Position correctly. Add a row of data. Name set to 1, 1. Vector set to -13, 0.36, -170.85. Save. Next, adjust the position of the arm when the AK weapon is equipped with a sight. Set the values to -6, 0.36, -139.5. Run the game. The sights are in the correctly position. Add a row of data. Name set to 2, 1. Vector set to -6, 0.36, -169.5. Save. Next, adjust the position of the arm when the AWM weapon is equipped with the sight. Set the values to -12, 0.36, -169. Run the game. The sights are in the correctly position. Add a row of data. Name set to 3, 1. Vector set to -12, 0.36, -169. Save. Next, adjust the position of the arm when the M4 weapon is equipped with a quadruple sight. Set the ID of the weapon accessory to 2. Run the game. Pick up an M4 weapon, press the 3 key, press the 5 key, in addition to the incorrect arm position. The problem is that the sight is a model which has value. It can result in the inside of the sight being visible, which is a bad effect. Zooming the sight when aiming is switched on solves this problem. Get the model of sight through the weapon object. Set the relative scaling. Here, set the x-axis scaling to 0.1 and the other axis to 1 without scaling. Run the game. Pick up an M4 weapon. Press the 3 key, press the 5 key. The sight display is OK. There is also a problem with the zoom function required when the quadruple sight is switched on. We implement the zoom function by adjusting the camera's FOV. Get the camera and call the sight FOV function. Set the FOV value to 28. The FOV is the camera's viewing angle. The default is 90. By adjusting the viewing angle downward, we can see a smaller area, and the object we see will be zoomed in. Set the arm position -40, 0.37, -169.35. Run the game. Position is correctly. Add a row of data. Name set to 1, 2. Vector set to -40, 0.37, -169.35. Save. Next, adjust the position of the arm when the AK weapon is equipped with a quadruple sight. Set the arm position to -6, 0.4, -168.50. Run the game. Position is correctly. Add a row of data. Name set to 2, 2. Vector is set to -6, 0.4, -168.50. Save. Next, adjust the position of the arm when the AWM weapon is equipped with a quadruple sight. Set the arm position to -30, 0.43, -167.54. Run the game. Pick up an AWM weapon. Press the 3 key. Press the 5 key. Position is correctly. Add a row of data. The row name is set to 3, 2. Vector is set to -30, 0.43, -167.54. Save. Arm position adjustment complete. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to make a function to turn on the sight. First, we will make the switch camera function. Open my calculator. Add the function named switch camera. Tap aiming. Add an input parameter. Named is first. Tap boolean. Indicates whether you want to switch to the first person mode. Set the arm visibility. Use the isFirst variable to set visibility. Check propagate to children object. Show the arm model when in the first person. Hide the arm model when not in the first person. Set first person camera activation. Use the isFirst variable to set the activation. Activate the first person camera when it is in the first person. Deactivate the first person camera when it is not in the first person. Set the character model visibility. Use the isFirst variable not to set the visibility. Check propagate to child objects. Set third person camera activation. Use the isFirst variable not to set the activation. Add comment. After switching modes, the weapon object needs to be attached to the corresponding model. Get the handheld weapon and call the setTransform function. Use isFirst to add a select node of type transform. Setup transform. In first person, call the getSocketTransform function via the first person arm model. Set the socket name to weapon socket. In the third person, get the slot transform function via the third person arm model call. Get player controller. Convert to make player controller. Call the calculate handhold weapon socket function. And set socket's name. The weapon is then attached to the corresponding model. The position rule is set to snap to target. The rotation rule is set to keep word. Add the select node. Use it first to set the index. Use the character model to set false. Use the first person arm to set true. Connect parent. Get skeletal mesh using the handhold arm. Call the set visibility function. Set visibility to true. Select pubg to children. Add comment. In the case of a quadruple sight, the model needs to be scaled. Determine first if there is a sight in the handhold weapon. If there is a sight, determine whether the sight ID is equal to 2. Get the model of the sight from the handhold weapon object. Set the relative scaling of the model. If it is equal to 2, then it proves to be a quadruple sight. Set the x value to 0.1, the y value to 1, and the z value to 1. If it is not a quadruple sight, set the x value to 1, the y value to 1, and the z value to 1. In the case of a quadruple sight, use the first-person camera to call the set FOV function. Set the FOV value to 28. If not a quadruple sight, set the FOV value to 90. With a quadruple sight magnifying the screen's contents, it is possible to see the magnified arm and not want to see the magnified arm, so head the first-person arm model if it is a quadruple sight. Add comment. Then, set the arm position. First, determine if it is a first-person model. In the previous lesson, we created a data table that holds the arm position information. Get the weapon ID from the handheld weapon object, promote it to a local variable, and name it weapon ID. Get the same object from the handheld weapon object and determine if the same object is valid. If it is valid, get the site ID, promote it to a local variable, named site ID. If invalid, set the site ID to 0. Call the getDataTable node. Set the data table to DT arms location. Add the append node. Use weapon ID to set the A value. The B value is underlined. Use site ID to set the value of C. Set to rule name. Get the arm model and call the set relative position function. Use the position values from the data table. Add comment. Finally, determine if there is an equipped helmet, if switching to third person, and if there is a need to hand the hair. Loop. Get the atom tab. Equal to helmet. End. Is first. Not. If in third person and has a helmet, head the hair. Add comment. Compile, save. Switch camera function complete. Next, test to turn on the site. Open event graph. Call the switch camera function after the hold down aiming. Animation has finished playing. Setting the first person to true. Next, add sight to the weapon. Enter an event is response to keyboard key 1. Add the spawn actor node. Set the class to atom weapon ACC. Make transform. ID is set to 1. SN set to 111. Number is set to 1. Get controller. convert to my player controller and call the equipment accessory function. Connect the accessory weapon object. Get the handheld weapon object. Respond to keyboard 2 key input event. ID is set to 2, SN set to 222. Run the game. Pick up a weapon. Press the right mouse button. The weapon is not in the correct position. Open the switch camera function. The socket name was not set when the weapon was added to the model. Calculate the socket. Call select node using its first. Set to false. Set true to weapon socket. Set to socket name. There is one more area of problem. After determining whether the site is true or not, you also need to determine whether it is currently a first-person view. Run the game. Pick up a weapon. Hold down the right mouse button. Turn on the sights correctly. Run the game. Pick up a weapon. Press the keyboard 1 key. Press and hold the right mouse button. Turn on the sight correctly. Run the game. Pick up a weapon. Press the keyboard 2 key. Press and hold the right mouse button. Turn on the sight correctly. Hello everyone, I'm Big Cat. In this lesson, we are going to refine the opening of the sight function. Let's start by making the trigger mechanism for opening the sight. In the previous lesson, we made a way to trigger the aiming without the sight on when the right mouse button is held down. Let's create a way to trigger the aiming to open the sight when the right mouse button is clicked. Open the event graph of my player controller. How do you distinguish between a right mouse click or a long press on the right mouse button? This is determined by the time the mouse is released with one press. Get the get time seconds node when the mouse is pressed. This node will return the current program runtime in seconds. Promote to a variable named right pressed time. Category weapon aiming indicates the time when the mouse is pressed. Copy the node. Subtract the time when the mouse was pressed. This value is the total number of seconds from when the mouse was pressed to when it was released. Print this value. Run the game. Press the right mouse button. You can see the time printed out. A normal right click should take less than 0.1 seconds or so. If it is less than 0.15 seconds, we consider it a click operation. If it is greater than 0.15 seconds, we consider it a hold operation. When the mouse is released, get my character and first determine if the weapon is currently being held. If aiming is currently on, call the switch camera function in my character. Switch to third person. Then call the hold aiming function. Play the unaiming animation. Then set the open sight to false. If the sights are not currently on aiming, then determine if the mouse press time is less than 0.15. If it is less than 0.15 seconds, set its sight aiming in my character to true. Set hold aiming to false. If it is not less than 0.15 seconds, determine if the mouse is currently being held down for aiming. If so, set hold aiming to false. Set the aiming state to false. Call the hold aiming function in my character. Play the unaiming animation. Call the update weapon display function in my character. Make the rewards hold aiming custom event connect here. Compile and save. Open my character's event graph. When the animation is finished, first determine if the sight aiming mode is on. If so, then call the switch camera function. Then determine if it is currently playing a console aiming animation. If so, set the aiming state to false. Compile, save. Open my player controller. Here you need to connect. Run the game. Fill that by holding down the right mouse button and clicking the right mouse button. So far, it feels good, but if you click the right mouse button, the forward animation can be played fast. Open my character. Add function. Named set is sight aiming. Category as aiming. Add an input parameter. Named is sight aiming. Of type boolean. Set the is sight aiming variable first. If it is true, set the playback rate of the aiming animation to twice speed. Compile and save. Open my player controller. Find the two places where the is sight aiming variable is set and call the sight is sight aiming function instead. Add a comment, compile, and save. Open my character's event graph. Before each animation, set the animation rate to 1. Add a comment, compile, save. Run the game. Open the site aiming again, and the animation becomes faster, so that it looks much more comfortable than it did earlier. When performing the post switch, you have already created the third-person camera head change in the previous lesson, and you will also need to change the camera head when in first person. Next, make the first-person camera head change function after switching poses. Open my character's viewport. The relative positions of the two cameras should always be the same. The head of the third-person camera is 100, and the head of the first-person camera is 75. The difference is 25. When moving the third-person camera, move the first-person camera at the same time, and keep a constant head difference of 25. Open the event graph of my player controller. Find the Update Camera Position area. After setting up the third-person camera, call the first-person camera via my character. Call the Set Relative Location function. Get the current relative location of the camera. Expands the sight position. Only the height value of the camera needs to be changed. So, connect the x value and y value directly. The z value is subtracted from the value from the LERP by 25. Set to the z value. Compile. Save. Run the game. Pick up a weapon. Open the sight to aim. Press crouch. Press prone. Press crouch. Press crouch. Hello everyone, I'm Big Cat. There are some restrictions when opening the sight aiming that prevent it from being opened, or when performing some action that will automatically turn off the sight aiming. In this lesson, we will make these restrictions. Find the discard weapon function. When discarding a weapon, in addition to checking that it is not currently in a prone position, you will also determine that it is not currently sighted in. Find the move function area. When aiming from a prone position, you cannot move. Use character to find out if the weapon is currently in a prone position. Then, find out if you are currently aiming. You can only move if you are not prone and aiming. Copy and paste. Do the same when pressing the left or right button. Find the area that responds to the aim button. Aiming is not allowed when moving from prone. Get prone state via character. Access forward or backward is not equal to 0, or access left or right is not equal to 0. And this state is prone and moving. Determine not. And get whether the sight are currently on. Is not on. Compile. Save. Run the game. Pick up a weapon. Switch to prone. Open the sight to aim. Press to discard weapon. Discard weapon disabled. Press to move. Unable to move. Cancel aiming. Continuous movement. Press to aim. Cannot aim while moving. When aiming with the sight on, all pause switches with anything to do with the on position will cancel the aiming state. Let's start by modifying the execution logic of the reverse hold aiming custom event. First, determine as to whether or not sight is currently on. If yes, then cancel the aiming. If not, then cancel hold aiming. Find the area that responds to the jump button. Remove the node related to determine the aiming state. Call the reverse hold aiming event after the prone to crouch execution. Find the response to the crouch button area. Call the reverse hold aiming event after the prone to crouch has been executed. Find the area that responds to the prone button. Call the reverse hold aiming event after the prone to stand execution. Set is aiming to force when moving from crouch to prone. Set is aiming to force when moving from standing to prone. Run the game. Pick up a weapon. Attempt to switch between prone. All toggles related to prone will turn off aiming if sights are on. When changing or taking back your weapon, you need to unaim if you are currently aiming. Friend the weapon change area. If the handheld weapon is returned, first set is aiming to force. Then call the reverse hold aiming function. When changing weapons, also cancel aiming. Copy and paste. Run the game. Pick up two weapons. Open aiming. Press X to take back the weapon. Display is correctly. Press 1 or 2 to hold weapon. Change weapons. Correctly display. If a montage animation is currently playing and it is not a firing animation, you cannot press aim or open the sight to aim. Friend the aiming area. Get the currently playing montage animation via my character. Not or get the tab of playing montage animation. Tab equals fire. Connect to end. Compile, save. Run the game. Pick up two weapons. Right-click when switching weapons. Aiming is not enabled. Right-click after the weapon. Hello everyone, I'm Big Cat. In this lesson, we are going to make an accurate aiming feature. What is accurate aiming? Run the game. Pick up a weapon. With the sight aiming on, there will be a shake in the arm. We want to do with accurate aiming to stop the arm shake when the user presses the shift key for a duration. After the duration is over, you need to wait a while before using accurate aiming again. Currently, the arm's shake is a bit too much by default. Open FPS aim blueprint and open the status machine. Open the aiming idle animation. Here, there is a play rate property. Adjust it to 0.8. Compile, save, run the game. Pick up a weapon. With the sight aiming on, the arm shake slows down a bit. Accurate aiming will use some data which we save in a data table. Create a folder in the data table structure folder. And name it aiming. Aiming-related structure tables are placed in this folder. Move the arm location structure into the aim folder. Create a structure named STAimAccurately. Open it. Set the first variable name to arm's normal rate, and tap float. Indicates the rate at which the animation plays if the aiming state arm is normal. Add a variable named arm's accurately rate. Of tap float indicates the rate at which the arm animates in the accurate aiming state. Add a variable named duration. Of tap boolean indicates the maximum duration of accurate aiming in seconds. Save and close. Create a folder in the date table folder named aiming. Aiming related date tables are placed in this folder. Move the arm location date table into the aim folder. Create a date table using STAIM accurately named DT-aim accurately. Open it. Add a row of data. Set the default arm animation rate to 0.8. Set the arm animation rate to 0 for accurate aiming. Duration is 3 seconds. Save and close. Open my player controller. Add a variable named accurate remaining. Of tap float. Category as weapon aiming. Indicates the time remaining for which you can calculate aim accurately. Compile. Initialize this variable in the begin play event. Add the get date table node. Select the DT-aim accurately date table. There is only one row of data in this table, so row name is run by default. Promote the data to a variable named aim accurately datas and category weapon aiming. Initialize the accurately aiming remaining time variable. Add comment. Compile. Next, set the arm animation rate. Open my character. Add a variable named isAimAccurate. Tap boolean. Category as character state. Indicates whether the current state is being accurately aimed. Compile and save. Open FPS aim blueprint. Check the play rate variable. This will set the value. Add the variable named aim rate. Tap float. Indicates the play rate value for the aiming idle animation. Set the default value to 0.8. Set this variable to the animation. Open event graph. Add the sequence node. Here, the MyCharacterObject reference is called for neatness of the linkage. Add the getDateTable node. Select the DTMAccurately date table. Expand the data. Use the MyCharacter reference to get the current aiming accuracy status. If yes, set the aim rate variable with the accurate aiming rate. If not, set the aim rate variable using the normal aiming rate. add a comment. Then we make a special call to set aim rate to 0 if we are currently equipped with a pubgmobile sight. Get the player controller. Get player state. Convert to my player state. Get the handheld weapon object. Determine if it is a valid. If valid, get the sight object. Determine if valid. If valid, get sight data. Expand. Determine if sight multiplier is 4. If 4, set aim rate to 0. Add comment. Compile and save. Next, make the accurate aiming on. Open my player controller. Find the area that responds to a shift button press. Modify the comment. When the shift button is pressed, first determine if the sight's aiming state is currently on. If not, connect the wrong press variable. If yes, determine if the time remaining for accurate aiming is greater than 0. If the remaining time is greater than 0, set accurate aiming to true. When the shift button is released, set accurate aiming to false. Add comment. Compile. Save. Run the game. Pick up a weapon. Open aiming. Press Shift to stop the arm shaking. Release the Shift key and the arm resumes shaking. Next, make a limit on the duration of accurate aiming. Add a function named Update Accurate Remaining. Category as Weapon Aiming. This is used to update the remaining time for accurate aiming. Add an input parameter named delta. Of type float. This is used to indicate how long the game will take to run for one frame. Go back to event graph and call this function in the event tick event. Go to the function and start implementing the logic. First, determine if accurate aiming is currently in progress. If so, determine if the time remaining for accurate aiming is greater than 0. If it is greater than 0, reduce the remaining time. Use the remaining time to subtract the delta value. Then the clamp node is called. The minimum value is 0. Call aim accurately data and expand. Set the duration to the maximum value. The purpose of this clamp node is to limit the maximum and minimum values of this value. The value is then set to the accurate aiming remaining time variable. If there is currently no more time left, set the accurate aiming state to false. If it is not currently accurate aiming, increase the remaining time. Copy the node. Change the subtractive node to an additive node. Compile and save. Open event graph. Add real-time printing of accurate aiming time remaining. Set the delta variable. Run the game. Pick up a weapon. Turn on aiming. Press Shift to stop the arm shaking. After 3 seconds, the arm automatically starts shaking. This is because after 3 seconds, the remaining time is 0. Looking at the printout, you can see that the time remaining starts to increase when the arm starts to shake. Accurate aiming can be switched on as long as there is currently time remaining. When the accurate aiming time remaining is 0, the arm starts to shake. Delete the test node. Add comment. Compile. Save. The accurate iron and big cat. Starting with this lesson, let's start making weapons firing related function. In this lesson, we will start by creating some basic functions for firing. Let's start by creating weapon firing modes. Our weapons have up to 2 firing modes. One is single shot, and one is automatic. Single shot mode means that each time the fire button is pressed, it will only fire once. Full auto mode means that if you press the fire button and don't release it, you can keep firing until the magazine is empty. All weapons have a single shot mode, and some have a full auto mode. Create an enumeration in the data's enu folder named eShoot mode. This is used to indicate the firing mode. Open. New. Named single indicates a single shot mode. New. Named auto indicates full auto mode. Save. Close. Open item weapon. Add a variable named shoot mode, and the tab eShoot mode indicates the current shooting mode of the weapon. Add function named switch shoot mode. Category as public, used to switch the weapon mode. Get whether there is an automatic mode from the weapon data. If auto mode is available, determine if the current mode is single shot. If it is single shot, then set the firing mode to auto. If it is not single shot, then set the firing mode to single shot. Compile, save. Open my player controller and respond to the Change Fire Mode button. Get the currently hold weapon object and determine if it is valid. If valid, call the switch fire mode function in the weapon object. Add comment. compile, and save. Next, create the firing logic. Open item weapon. Add a custom event named press fire. This event is called when the current trigger fire. Add a custom event named release fire. This event is called when firing is currently stopped. Add sequence node. Add the get node. Enter is entry, and then out the door from exit. Open is to open the door. You can only enter the door if it is open. Close is to close the door. If the door is currently closed, enter will not execute exit. After executing toggle, if the door is currently open, it will close the door. If the door is currently closed, it will open the door. The door is closed by default. When fire is pressed, the door is opened first. Then enter the door. Closes the door when firing is stopped. Add sequence node. First, to determine if the current weapon has full auto mode on. If it is full auto mode, fire automatically. Get the firing mode and determine if it is full auto mode. If it is in full auto mode, add the delay node. Get the minimum time between firing bullets for this weapon from the data. Set to delay. When delay is complete, execute enter. This will automatically loop through the firing logic. Then, determine if the number of bullets in the current weapon is greater than 0. If it is not greater than 0, then there are no bullets and a message is printed. If there are bullets, call the playFire sound function. Call the playFire flash function. The number of bullets is reduced by 1. To test to see the effect, you can print the current bullet count before checking the bullet count. The fire logic is implemented here first. Compile and save. Next, respond to the fire button. Open my player controller's event graph. Respond to the fire button. Firstly, let's limit the situations where you can't fire. First, get the handheld weapon object. Which cannot be empty. Then, enable move, which must be true. An enable move of false means that the character is currently in the middle of a switch to a spawn and cannot fire at this time. You cannot fire when the Alt key is pressed. Use my character to get whether the character is currently in prone. If it is prone, end. Get the character's movement component. Get the current character's movement speed. Call the vector length node. Determine if it is not equal to 0. You can't fire when moving from a prone. There is also a case where the character cannot fire while in the air. Use the movement component to call the is falling node. If it is true, it proves that it is in the air. This value will be true when the character jumps off the ground. The character also cannot fire when performing some actions. Open my character's play montage function. First, look at what actions use montage animation. Equipping a weapon, discarding a weapon, changing magazines, changing bullets, firing, and using an item. Of these actions, only firing can be continued when firing. None of the other actions can perform the firing action when executed. Back in my player controller. Get whether the montage animation variable is currently playing through the MyCharacter object. If not, or get the type of montage animation that is currently playing. Determine if it is equal to the firing animation type. Make determination. If no montage animation is currently playing or a fire animation is playing, call the press fire function of the handheld weapon object. When the fire button is released, first determine if the handheld weapon is valid. If valid, call the release fire function of the handheld weapon object. Add a custom event named release fire. Connect the logic for released the fire button. Easy to call earthfire. Add comment. Compile, save. Need to stop firing if the current character is firing when some action is executed. Friend the change weapon function area first. Handheld weapons are taken back and the firing needs to be stopped. Call the release fire event. Need to stop firing when changing handheld weapons. Call the release fire event. When the Alt key is pressed, firing needs to be stopped. Call the release fire event. When the character's pulse is switched, all related to the prone pulse need to stop firing. Friend the response crouch button area. Fire needs to be stopped when prone to crouch pulse. Call the release fire event. Friend the area that responds to the prone button. Fire needs to be stopped for all prone toggles. Call the release fire event. Friend the area that responds to the jump button. Need to stop firing when switching from prone to crouch. Call the release fire event. Stop firing after jumping. Friend the area that responds to fire. Here you should determine not. compile, and save. Open item weapon. Do not determine if there are bullets yet. Run the game. Pick up a weapon, press the left mouse button, and a flash and sound is played. By default, the weapon is in single shot mode. Press the B key. It now switches to full auto mode. Press the left mouse button and the weapon fires continuously. Determine the number of bullets. Delete the test. Hello everyone, I'm Big Cat. In the last lesson, we made the basic logic for firing. When firing, the third-person character should change to the aiming pose, and the firing animation should play. At the end of firing, hold the aiming pose for 3 seconds, and if it doesn't continue firing, change back to the non-aiming state. When firing, if the character is currently in first person, the firing animation is played, but no weapon flash is played. In this lesson, we'll create an animation to handle the firing. Let's start by triggering the firing flash particle effect. Open item weapons event graph. Add a variable named canPlayFiringFlash. Tap Boolean. This indicates whether or not the firing flash is currently playable. Determine the canPlayFiringFlash variable before calling the playFiringFlash function. Compile and save. Open the side aiming function of my character. With aiming on, set the handheld weapon not to play the fire flash. With aiming off, set the handheld weapon to play the fire flash. Compile, save. Open item weapon without determining the number of bullets remaining. Set can play flash to true by default. Run the game. Pick up a weapon, fire, and the fire flash particle effect is played in third person. Turn on the sight to aim. Fire, no fire flash particle effect is played in first person. Next, create a function that plays the character's firing animation. Open item weapons event graph. Add a variable named myCharacterRef. Tap myCharacter. Add a variable named myPlayerStateRef. Of tap myPlayerState. Add variable named myPlayerControllerRef. Tap myPlayerController. Add variable named myGameInstanceRef. Tap myGameInstance. Get player character. Get player state. Get the player controller. Get game instance. Add comment. Add sequence node after determining that the number of bullets is greater than 0. Set the current aiming state to true. Then call the update weapon display function. Call the calculate handhold weapon socket function via my player controller and set it. Determine if the sights are currently aimed. If so, play the ARM model's firing animation. Get the ARM model via my character. Get the animation instance and call the play montage animation function. Set the montage file to ASFPS aim fire montage. The total playing time for this animation is 1.083 seconds. Set the playback rate to 4. Run the game. Pick up a weapon, open the sight, and fire. Play the firing montage animation correctly. If the sight is not currently on, call the play montage function in my character. Set the tab to fire. Open the play montage function. Set the play rate of the prone fire animation to 0.466. Set the play rate of the crouch fire animation to 2. Set the play rate of the stand fire animation to 2. Run the game. Pick up a weapon and fire. Switch to crouching, fire. Switch to prone position, fire. The firing animation plays correctly. The firing animation is complete. Return to item weapon. Add comment. Compile, save. After firing, the character will automatically switch to the aiming state. If it does not continue firing, it will continue for 3 seconds before automatically switching to the non-aiming state. Next, make this function. Get the current runtime when firing. Promote to a variable named fire time. This variable indicates the time when the fire is fired. Compile and save. Open my player controller. Next, check the time in real time via tick and cancel the aiming state when firing for 3 seconds. Add a function named stop aim state. Category as weapon aiming. Call it an event tick. Add comment. Open the function. First, determine that it is not press and hold to aim. End. Not with the sight on. If it is not hold to aim and is not aiming with the sight on. Get the handheld weapon and determine if it is valid. If valid, get the time to fire. Determine if the time to fire is greater than 0. If equal to 0, the weapon is not firing. If greater than 0, get the current game time. Subtract the time to fire. This time is the duration of time since firing. Determine if this time is greater than 3. If it is greater than 3, it proves that the firing has lasted for 3 seconds. Set the aiming state to false. Get the handheld weapon object. And set the firing time to 0. Compile and save. Go back to event graph. Find the press shift key function. When the shift key is pressed, call the reverse hold aiming function if the sight aiming is not on. Find the press aiming button function. Add sequence node before performing aiming. Get the handheld weapon object. If the handheld weapon is valid, set the handheld weapon's fire time to 0. The purpose of this is that if the user actively presses aim, it will not automatically cancel the aiming state after 3 seconds. Compile, save. Here, set its aiming to false first. Run the game. Pick up a weapon. Fire, and it automatically changes to the aiming state. If you do nothing, the aiming state is automatically cancelled after 3 seconds. Fire and hold aiming at this time. The aiming state is not automatically cancelled after 3 seconds. Hold Shift to move and automatically cancel the. Hello everyone, I'm Big Cat. In this lesson, we are going to create a function for changing magazines. To change the magazine, we need to query the current number of bullets. So we will first create a function to query the number of bullets. Open my player state. Add a function named getAmmoAmount and category as ammo. Add an input parameter named ID and type name indicates the bullet ID to be queried. Add an output parameter named amount of type integer indicates the number of bullets. Determine if the bullet number is equal to 1. If it is equal to 1, get the 556 bullets and return it. If it is not equal to 1, get the 762 bullets and return it. Compile and save. Before performing a magazine change, you need to check the current number of bullets remaining and the number of bullets in the weapon. Open item weapon. Add a function named check ammo amount. Category as private. Add an output parameter named need amount of type integer. This value differs to the number of bullets needed to fill the magazine, but returns the number of bullets in the backpack if there are not enough bullets in the backpack. If for some reason the magazine cannot be changed, then 0 is returned. Get the weapon data. Extend the data. Call the get number of bullets function in my player state. Set the weapon ID. Promote the number to a local variable named remain amount. Add comment. Determine if the number of bullets remaining is greater than 0. If it is not greater than 0, then there are no bullets and return 0. If there are remaining bullets, get the capacity of the current weapon's magazine. Determine if the current weapon has a magazine. If there is a magazine, get the magazine data. Expand. Promote the magazine capacity to a variable named clip size. If there is no magazine, get the data via the weapon object. Extend. Set the default magazine capacity to the magazine capacity variable. Add comment. Next, calculate the number of bullets needed to fill the magazine. Subtract the number of bullets in the weapon using the magazine capacity. Promote the result to a variable named need. Determine if it is greater than 0. If it is equal to 0, then the current weapon magazine is full. Return 0. If greater than 0, add the clamp node. The value is set to need. The maximum value is set to the number of bullets in the current backpack. The minimum value is set to 1. Return. Add comment. Compile, save. Open my player controller's event graph. Respond to the reload button. The first thing to do is to determine the conditions under which you cannot perform a reload. This condition is basically the same as firing. Copy. and passed. Remove the judgment of prone and moving. If a magazine change is performed when you are prone on your back and moving, you will stop moving. Get whether a montage of animations is currently playing via my character. If no animation is playing, or the animation playing is firing. Make a determine. If the character is currently playing a montage animation, it means that an action is being performed, and the magazine cannot be changed while the action is being performed. If no montage animation is currently being played, or the animation being played is a firing animation, then the magazine change logic will begin. Next, create the magazine change logic function. Open item weapon and add a function named reload clip. Category as public. Go back to my player controller. Get the currently hold weapon object from player state. Determine if it is valid. If it is valid, call the reload clip function in the weapon object. Add comment. Go to the reload function. Call the function that checks the number of bullets. Determine if the number is greater than 0. If greater than 0, add sequence node. Call the play montage function via my character. Select the montage tab to reload. Then use my character to get whether or not you are currently aiming. Then get whether the sight is on or not. Determine if you are aiming or have a sight on. If so, cancel the aiming state and call the reverse hold aiming function in my player controller. Compile, save. After playing the animation, bound the animation play complete event. Bound in begin play. Bound the end of reload playback event. The event is named event reload end. Determine if it is a magazine change. Get the play montage tab via my character. Determine if the tab is a reload. If it is, the number of bullets in the weapons magazine needs to be filled and the corresponding number of bullets in the backpack needs to be removed. Open item weapon. Add the function named filled clip and category as public. Go back to my player controller. Get the handheld weapon object and call the filled clip function. Add comment. Next, create the filled clip logic. Open the function. Call the check number of bullets function. use the required number plus the number of bullets in the current weapon. Set the number of bullets given to the weapon variable. Call the update bullet count function via my player state. Set the number of bullets used to the ID via the weapon data. Set the number. Here it is reduced, so add is not checked. Compile, save. The magazine change function is complete. Next, test. To make it easier to see the data, print the number of bullets in weapon and the number of bullets in backpack in real time. Open event graph. Print add event tick. Add append node. A value of 556. Get the current 556 bullet count from player state and set it to the B value. C value is 762. Get the current 762 bullets via player state, set to the value of D. E value is weapon. Get the weapon object from player state. Get the number of bullets for the weapon, and set it to the F value. When there is no weapon in hand, this object is empty and will an error to be reported. This is fine, we are just testing. Run the game. The ID of 556 bullets in the current backpack is 0, and the ID of bullets in the 762 is 0. The number of bullets for the weapon is 0. Pick up a weapon. Pick up the bullets, and the 762 bullets in backpack becomes 30. Press the R key. The magazine change animation starts. When the animation finishes, the 762 bullets in the backpack becomes 0, and the number of bullets in the weapon becomes 30. Change to a full magazine. Pick up the 762 bullets again. Fire. The current number of bullets in the weapon is 20, and the 762 bullets in the backpack is 30. Press the keyboard R key. When the animation finishes, the 762 bullets in the backpack will be 20, and the number of bullets in the weapon will be 30. Fire until there are 5 bullets in the weapon. Press R. When the animation finishes, the 762 bullets in the backpack become 0, and the number of bullets in the weapon becomes 25. The magazine change logic is correctly. Delete the test node. Compile. Open for terminal. Here, if no bullets are connected, print. Compile, save. In this lesson, we make the magazine change speed and auto change function. Let's start by dynamically adjusting the magazine change speed. Different weapons change magazines at different speed, and equipping different magazines will affect magazine change speed. To adjust the magazine change speed, you need to adjust the speed at which the reload animation is played. Open my character's play montage function. Add an input parameter named play rate of type float. This indicates the playback rate. Only the reload animation will be affected by this input parameter. Prone reload animations use the play rate. Crouch reload animations use the play rate. Standing reload animations use the play rate. Compile, save. Let's first see how to calculate this playback speed. Open the weapon data table. Each weapon has a reload time. This time is the time it takes for the weapon to change magazines by default. Open the weapon accessory data table. Find the magazines. The magazine's rate for the quick magazine is 0.8. This means that when equipped with this magazine, the magazine change speed is 20% fast. Find the reload animation file. There are two of them, one for the prone reload animation and one for the standing reload animation. Open the prone reload animation. The whole animation takes 2.4 seconds to play. Open the stand reload animation. The whole animation takes 2.167 seconds to play. Multiply the magazine rate by the default weapon change time, then divide the animation time by the result to get the final playback rate. Open my game instance. Record the montage animation playback time in this. Create a variable named replace clip time stand. Tap float. And category as animation. Indicates the reload time when in standing position. Create a variable named replace clip time prone. Tap float. Category as animation. Indicates the reload time when in prone position. Open the magazine change function of item weapon. The first step is to calculate the animation rate. Add the sequence node. First, determine if the magazine object is valid. If it is valid, then the weapon is currently equipped with a magazine. Get the magazine data and expand it. Multiply the default magazine change time for the weapon by the magazine rate. Get the weapon data. Expand. Multiply using the magazine change time. The multiplied value is promoted to a local variable named reload rate. If no magazines are equipped, then set the weapon's default magazine change time to the reload rate variable. Then, determine if the current character is in a prone position. If it is, divide the reload rate by the time of the prone montage animation. Set the value to reload rate. If the character is not in a prone position, divide the standing montage's animation time by reload rate. Set the value to reload rate. The animation rate is calculated. Add comment. Set the playback rate to reload rate. Compile. Save. Next, test the magazine change speed. Before playing the montage animation, print the playback rate. Open my character's event graph. Delete all test node. Respond to keyboard 1 key. Add the spawn actor node. Set class to item weapon ACC. Make transform. ID set to 30. 30 is the quick magazine for the rifle. SN set to 111. Amount is set to 1. Get controller. Convert to my player controller. Call equip accessories function. Get the handheld weapon object. Attach weapon accessory object. Open game instance. Set the standing magazine change time to 2.167. Set the prone position magazine change time to 2.4. Compile, save. Next, need to change the type of a variable. Open the structure for weapon accessories. Change the type of weapon IDs to name. Save and close. Open the date table for the weapon accessory. It will not affect the previous data. Open the equip accessory function of my player controller. Change the type of weapon IDs to name. Reset. Compile, save. Run the game. Pick up a weapon, pick up an ammo. Press the R key to perform a magazine change. At this point, the M4 weapon plays at the rate of 0.985 with no magazine equipped. The standing montage animation playtime is 2.167 seconds. Use 2.167 divided by 0.985, which is 2.2. The default magazine change time for the M4 in the date table is 2.2 seconds, proving that our calculations are correct. Firing. Pick up the ammo. Press keyboard key 1 and the magazine is changed to a quick magazine. Press the R key. At this point, the rate is 1.23125. Use 2.167 divided by 1.23125, which is 1.76. The default velocity is 2.2 multiplied by the magazine rate of 0.8 equals 1.76. This proves that the rate of play is calculated correctly when the magazine is equipped. Delete the test node. At the end of each fire, automatically check if there are any bullets in the magazine, and if there are none, perform an automatic magazine change. Next, make the automatic magazine change function. Open the event graph of my player controller. Add a custom event named execute reload. Connect the reload event. The purpose of this is that this logic can be called elsewhere. Bound the end of fire event, named event fire end. This bound the third person fire end event. If the sight is currently on, the first person arm fire animation is played. So you also need to bound the first person fire end event. Get the first person arm model via my character. Get the animation instance. convert to FPS in blueprint. Bound the fire end event. Also execute event fire end custom event. Get the handheld weapon object and get the number of bullets in the weapon. If the number of bullets remaining is 0, execute the magazine change logic. Run the game. Pick up a weapon, pick up ammo, reload. Pick up ammo, switch to auto mode, shoot all the bullets. Automatically reload when finished. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. Sniper weapons need to change bullets after each shot. This lesson is about making functions related to changing bullets. Open item weapon. Add the function. Name it change bullets. And category is public. Get the weapon data and expand it. Determine if the time to change bullets is greater than 0. If it is equal to 0, then the weapon does not need to be changed after each shoot. If greater than 0, determine if the number of bullets in the weapon is greater than 0. If greater than 0, call the reverse hold aiming function via my player controller. Call the play montage function via my character. Set the tab to reload bullet. Compile, save. Open my player controller's event graph. Call the change bullet function at the end of the firing animation. This allows a bullet change check to be made after each fire. After the bullet change animation has finished playing, if it is not a magazine change, then it's a bullet change. If it is a bullet change, set the aim state to true via my character. Then call my character's update weapon display function. Call the calculate hold gun socket function. And set the socket name. Compile, save. Run the game. Pick up a sniper rifle, pick up ammo, reload. Fire. Automatically change bullets after firing. Open the sight to aim. Fire. We want to return to sight on after changing bullets. If it is currently open, the sight should open automatically after a bullet change. Open item weapon and add a variable named sight open of type boolean. This indicates whether or not the sight is currently on. Open the change bullets function. Set the sight open variable before cancelling the aiming. Get whether the sight is currently open for aiming via my character. Sight. Compile, save. Go back to the event graph in my player controller. After setting the aiming state, determine if the sighting is on. Before changing bullets. If so, call the hold aiming function via the my character object. checking the forward direction. Call the set aiming function to set whether or not the sight is on, and set it to true. Finally, update the weapon display whether or not the sight is on. Compile, save. Run the game. Pick up a sniper rifle. Pick up ammo. Reload. Fire. Return to aiming when bullet change is complete. Open the sight to aim. Fire. Return to aiming with the sight on when the magazine change is complete. There is currently a problem where if you press the fire button very quickly, you will fire multiple bullets before changing bullets. This is not right. The weapon cannot fire while executing the bullet change animation. You need to wait until the bullet change is complete before you can continue firing. Open atom weapon. Add a variable named needReloadBullet of type boolean. Indicates whether a bullet change is required. After firing, use the weapon data to determine if the bullet change time is greater than 0. If it is greater than 0, then set needReloadBullet to true. Compile, save. Open the event graph of my player controller. If it is a bullet change, get the handheld weapon and set need to change bullet to false at the end of the bullet change. Not here. If you are changing magazine, you should also set the need to change bullets state to false. This is because after the magazine has been changed, there will be a bullet change animation performed. Set need to change bullet to false via the weapon object. Friend the area that responds to a press of the fire button. Add a judgment. Get the handheld weapon object. Determine if it needs to be changed, and continue if it doesn't need to be changed. Compile, save. Run the game. Pick up a sniper rifle. Pick up ammo. Quickly press the fire button. At this point, you can only continue fire after the bullet change animation has finished playing. Hello everyone, I'm Big Cat. In this lesson, we are going to make a firing limit. Let's start by making a prone movement limit. Find the area that responds to the Move button. If you are currently playing a firing animation or any other montage animation and are in prone position, you cannot move. Get the playing montage state from the MyCharacter object. If a montage animation is playing and is in prone position, Note: determine if the montage is not in prone position and is playing, you can move. Copy and paste to move the left or right. Compile, save. Run the game. Pick up weapon, pick up ammo. Switch to the prone position, reload, and press the move button. The character will not move at this point and will not move until the reload is complete. But now there is a problem. When firing, you need to stop for a few seconds before moving again. This is because we have set the auto aim for 3 seconds when firing. When in prone position, you can leave the aiming state on, because the default state in prone position is the aiming state. Open Atom Weapons event graph. Get the current prone state via my character. Get whether the sight is on or not. If you are in a prone position and are not aiming, the aiming state should be set to false, so not. Set the aiming state. Compare, save. Here, you also need to note run the game. Pick up weapon. Pick up ammo. Switch to prone position. Reload. Fire. Move. You can now move directly after firing. Switch to sniper rifle. Pick up ammo. Switch to prone position. Reload. Fire. After firing, the reload is performed automatically. After reload, you cannot move again immediately. This is for the same reason as before. Open the event graph of my player controller. Find the bound reload complete area. Get the prone state via my character. Note: set to the aiming state. Compare, save. Pick up sniper rifle, pick up ammo. Switch to prone position, reload. Fire. Once the reload is complete, you can move directly. Find the area that responds to the jump button. Copy and paste the judgment you just made before performing the prone to crouch switch. Compare and save. Find the area that responds to the prone button. All of the pause switches in this area are related to the prompt pause, so copy and paste the top judgment. Run the game. Pick up the weapon and pick up the ammo. Try to switch between pause-related switches when reload. None of them will switch. Next, make a running limit. If reload while running, cancel the running state. Friend the area that responds to the reload. Set the run state to false before executing the reload logic. Compile, save. If the magazine is currently being changed, pressing the run key is not valid. Friend the run key response area. Before setting the run state, need to determine if the related animation is currently being executed. Compile, save. Run the game. Pick up the weapon, pick up ammo, run. Reload. You can see the cancel running state. Fire, pick up ammo. Reload. Then press the run button. No running state is executed. If the magazine is being changed, the weapon cannot be changed. Friend the area that responds to changing weapons. Make adjustment call before taking back the weapon. Copy and paste. Add a judgment on whether the weapon take-back animation is being played. Compile, save. Determine when changing weapons as well. Copy and paste. Add a judgment for Equip tab. Compile, save. Run the game. Pick up two weapons. Press X while reload. Hello everyone, I'm Big Cat. There is a shake effect when a weapon fires. There are two parts to this shake. One is the screen shake, and the other is aiming shake. In this lesson, we will first look at how screen shake is created. For screen shake, we will use one of the camera shake functions provided by Unreal Engine. Use the camera shake class to implement this function. Let's start by explaining how to use this class. Create a folder in the blueprint folder named camera. Create a blueprint in this folder. Input camera shake. You can see that there is a class named camera shake. Select this class and click the Select button. Name it camera shake test. Open it. You can see that many default values can be adjusted to make the screen shake. Open my player controller. Respond to the keyboard 1 key. Get the player camera manage object. This object is dedicated to managing the character camera. Call the play camera shake function via the player camera manager. The shake class selects the camera shake test just created. When the 1 button is pressed, camera shake is executed. Open the camera shake test class. I will briefly explain these properties first, and then see the effect more visually by running them later. The first property, whether or not it is a single instance. If this property is unchecked, executing the shake again when the current shake has not finished playing will continue according to the current execution position. If this property is checked, the shake will be replayed if the shake is executed again when the current shake is not finished. This property controls the duration of the shake in seconds. If this value is less than 0, it means infinite time. When equal to 0, it means no shaking. First, set the duration to 1. Blend in time and blend out time. Adjusting these two values will make the shaking animation smoother. Shaking can be done in 3 ways. One is to rotate the shake's angle. One is to move the position of the shake. And one is to adjust the FOV of the shake. This can be done simultaneously or separately. There are 3 angular directions in rotational shakings. The first is pitch, which rotates along the x-axis. The second is yaw, which rotates along the y-axis. The third is roll, which rotates along the z-axis. Each of these angles has the same 4 attributes. The first is amplitude. This is the value of the range of the shake. For example, if this value is 90, then it means that the pitch angle has a shake amplitude of 90 degrees. This 90 degrees is the maximum pitch angle. This is not an effect angle, as it works with the duration, but the maximum pitch angle is 90 degrees. The second is the shake frequency, which determines the speed of the shake for the same duration. The third is the shake start position, which by default is random. If it is random, then the start shake position will be random. The other is start from 0. The start shake will be shaken from the current position. The last one is the V-form. The first is the sine wave, which means that the shaking follows a sinusoidal curve. This way, the shaking is smoother. The second is the pole north, which shakes out in a very similar way to a random effect. The shifting position and FOV shake mode have exactly the same properties as the rotation angle shake mode, except that the position is shifted or the FOV value is changed. The next step is to see the effect more visually in the game by adjusting these values. Set the duration to 5 seconds. Pitch angle is 90 degrees. Frequency is 1. Initial load date is 0. Compile and save. Run the game. Press the 1 key. You can see the screen rotate upwards up to 90 degrees, then downwards up to minus 90 degrees, and finally back to the start position. This process is a temporary sine curve movement. Note that the speed of movement at the final return to the starting position is significantly faster than at all other times. This is because there is not enough time left in that last station to move at the previous speed at the current frequency, so it gets faster. Set the blend out time to 1. The in and out times have a range value of 0 to 1, which is a proportional value. Compile and see. Run the game. Press the 1 button. You can see that the animation moves more smoothly in the final stage this time. Adjust the duration to 1 second. What effect will this have? Compile and see. Run the game. Press the 1 button. Firstly, the pitch angle does not reach the 90 degrees we set, and secondly, it does not move down. This means that the pitch angle we set is the maximum value and may not reach the set value depending on other variables. Secondly, each shaking animation must end at the starting position, which means that using the shaking function will not affect the original camera angle. Set the frequency to 10. Compile and see. Run the game. Press the 1 button. The screen shakes much faster than before. This means that the frequency value directly influences the speed of shaking. Set the start position to random. Set the frequency to 1. Compile, see. Run the game. Press the 1 button. Notice that it is shaky, but it is not actually shaky. Look carefully. Each time the shake is executed, the shake starts at a different position. The screen is first transiently shifted to a random position before the shake animation starts. This random start position will not exceed the maximum angle value we set. Next, look at the waveform. First, set the start position to start at 0. Then, set the waveform to be noisy. Compile, see, run the game. Press the 1 button. You can see that the trajectory is not seemingly random, but regular irregular motion trajectory. Finally, we look at what the instance does. The instance is currently unchecked. Run the game. Press the 1 key quickly and continuously. When keep pressing 1, the screen shake stops moving. When stop pressing 1, the shake animation starts to continue, and only one full animation is executed, which instance unchecked if the previous animation is not executed. Executing it again will continue the animation from the current position, and only the last animation will be executed. Check the instance. Compile, see. Run the game. Press the 1 key quickly and continuously. I can see that the animation plays normally, even keep pressing 1. When I don't keep press 1, the full animation plays once for the duration. This is where the single instance option comes into play. Open my player controller and delete the test node. Compile, see. Delete the test file. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In the last lesson, I explained how to make screen shake. In this lesson, we will create screen shake and crosshair offset function. First, let's make the camera shake class. We have 2 types of weapons, an automatic rifle and another is a sniper rifle. The difference between these 2 types of shake is relatively large, so make 2 camera shake classes. Create a blueprint in the camera folder. Select camera shake. And name it automatic rifle shake. Use this class for automatic rifle shake. Open it. Select the single instance. Set the duration to 0.3 seconds. Set boolean out time to 1. Set pitch amplitude to 8. Frequency is 1. Start position is 0 point. The waveform is a sine curve. Set the amplitude of yaw to -3. The frequency is 1. Set position is 0 point. The waveform is a sine curve. Save and close. Create blueprint in the camera folder. Select camera shake. and name it Sniper Rifle Shake. Use this class when shaking a sniper rifle. Open. It doesn't matter if a single instance is selected, because sniper rifle don't have burst mode. Set the duration to 0.7 seconds. Set the amplitude of the pitch to 50. Frequency is 1. Start position is 0.0. The waveform is a sine curve. Set the amplitude of yaw to -5. The frequency is 1. Start position is set to random. Waveform is noise. Save and close. Next, make the screen shake when firing. Open Atom Weapons event graph. Get the bullet change time from the data after firing. Determine if the bullet change time is greater than 0. If it is greater than 0, then it is a sniper rifle. Otherwise, it is an automatic rifle. Get Player Camera Manager. Call the Play Camera Shake function. If it is a sniper rifle, select the Sniper Rifle Shake class. If it is an automatic rifle, select the Automatic Rifle Shake class. Compile, save. Run the game. Pick up an automatic rifle. Fire. The screen has a shaking effect each time you fire. Pick up a sniper rifle. Fire. Shakes more than the automatic rifle. Add a comment. No matter how much the screen shakes, it will eventually return to its original position. Due to the weapon's recoil, there should be an upward shift and a small left or right shift in the sight each time you fire. Next, create the aiming offset function. After playing screen shake, add a sequence node. Let's start by calculating the offset value. Get the horizontal offset value from the weapon data. Horizontal offset random left and right. Add the random boolean node. Add select node. Set pin value as integer. If false, the value is -1. If true, the value is 1. This action is to random a value of 1 or -1. Multiply this value by the horizontal offset value. This gives us a random left or right offset value. Promote this value to a variable. Named ready yaw. This indicates the value by which the yaw angle will be offset. Then, calculate the pitch direction offset value. Get the vertical offset value from the weapon data. Promote this value to a variable. Named ready pitch. Indicates the value by which the pitch angle will be offset. Every time you offset the crosshairs, you should smooth the offset for better results. So, use timeline for smooth offset. Add a timeline and name it TL8 offset. Here, you need to pay special attention to the fact that the timeline is not executed in one frame, so it is necessary to finish the timeline once after each firing, and this time is a minimum interval between weapon firing. It is important to make sure that before the next firing starts, the aiming offset has been completed after the last firing. Otherwise, the offset position will be misaligned. Trying to implement this feature results in an indeterminate duration each time timeline is run, which needs to be determined based on the current minimum interval between weapon fires. So, the previous method of using timeline cannot meet this requirement. Here, we share with you other way to use timeline. Open. Add a track of float tab and name it time. Set the length of the timeline to 100 seconds. This time can be as long as it is greater than the maximum possible time. Add a key point. Set the time to 0 and the value to 0. Add key point. Set the time to 100 and the value to 100. Go back to the event graph. Before executing this timeline, you can set the duration of this timeline. Go through the weapon data and get the weapon firing interval time. Promote it to a variable named length. Since sniper rifle cannot fire in burst, the minimum interval between shots for sniper rifle is 0. If it is equal to 0, set length to 0.1 directly. Set length to timeline. Use the current time divided by the total time to get the entire timeline percentage. Promote to variable named %. Add variable named added per. Of type float, used to indicate the percentage value of the last time in the update process, called via my player controller to add the pitch angle value. Use the current percentage minus the percentage that has already been added to get the percentage that should be added this time. Multiply the total pitch value to be added by the percentage added this time to get the value that should be added this time. Add the yaw angle value through the my character controller call. Copy and paste. Use ready yaw. Set the current percentage to the added per variable. Then set the added per variable to 0 before each restart of the timeline. Compile, save. Run